Good morning, dear colleagues. Good morning to the 300 colleagues here in front of us today, coming from all over Europe. They come from the ocean up to the Eastern Europe and from Mediterranean to the Balkans. We managed to have plenty of you around you. And we know that we are interested today in this webinar on solution for low noise road surfaces. My name is Paviotti. I work in the European Commission, and I'm in charge of the noise file in the Directorate General for the Environment. And with me today,
Manuel Montero. I'm working for CINEA. CINEA is the Climate Infrastructure and Environment Executive Agency of the European Commission. And one of the programs that the agency is managing is the LIFE program, for which I work for. I welcome you all as well from my side.
And you know what, Manuel, this morning I was coming here, I was reflecting this solution for low noise road surface. Can you imagine all over Europe suddenly being quiet? I don't mean the complete silence, but quiet. You know, the people can talk, they can talk among themselves in the street. You can still see the cars and the buses, but you know, you can listen to the music and the birds if you're in a quiet area or in a park. You know what I've read one day, that roughly 1% of the cost, of the extra cost of real estate is comparable to 1 dB less noise. Can you imagine we convince all the people today to change all the roads? So we buy the houses before and we sell them the day after. We're gonna be millionaires, isn't it? Okay, so colleagues, I think we have a plan for today. But I have to give you, first of all, a policy reason why we're doing this webinar today. We have in the European Commission a policy to protect the effects of on human health of noise, and this was embedded into a plan, which was the Zero Pollution Action Plan. Now this plan is being deployed, and it will continue for the coming year. And in this plan, we also proposed a target of reducing by 30% by 2030 the number of people disturbed by transport noise. Now, on top of that, we have a regulation in place in Europe that manages the way the road vehicles in this case should be produced. So they need to be relatively quiet. And we have a directive that asks the competent authorities, the road authorities, the city authorities to put in place action plans and to contribute with solutions also on their side. And this is one of those. And in the recent report from March of 2023, where the Commission explained what happened on this directive, we stated that we would like to promote the use of low noise road surfaces, because these have a substantial contribution in that sense. So we have a reason that comes from policy, but I think, as I mentioned somehow in a joke, that yes, that is a benefit for the citizens, and the citizens do perceive this benefit. And this turns out into better health, but this is also monetized in the increase on the real estate value. And we would like today to go through a program, a very dense program, but I would say, shall I say the best, without using probably the best, but clearly stating the best experts in the topic, on the topic in Europe and probably worldwide. How does it work? In the morning, we will have a series of presentations from these experts, and these series of presentation, they will introduce the different aspects of the topic. So for instance, what is the legislation and the standards around this? What are the technologies that have been developed? How you can introduce in the action plans, and why these technologies can be cost effective. And then in the late morning and in the afternoon, we will have again some introductory presentation, but with the aim of developing and opening up for a discussion amongst us. And we would like to involve you to ask questions to the panelists. And we will take care of answering not only all your questions, but also trying to understand if out of this workshop we can identify some needs for the future in addressing what still hampers the deployment of low noise road surfaces. And this said, I want to recall we start in a few minutes at 9:15. And we start with Fabienne Anfosso-Ledée on an overview on low noise pavement legislation and standards. We will go on with Bert Peeters on lessons learned from low noise pavement in urban areas. Giulia Custodi will talk us about the Paris experience on the 3 innovative ASPHALT formula. Patrizia Bellucci will describe the Italian national road, how they adopt the low noise road surfaces. And Manfred Heider will talk about the standardization of acoustic assessment of low noise pavement. Before we start, we have Manuel that will tell you one more thing. Not only at the end of the day, you will be convinced that you will go out and ask for low noise road surfaces, but Manuel will show you even how the European Commission provides funding for this reason. Manuel.
I'm going to speak about money. It was money to find the idea. So if we can, colleague, go with the presentation. Can you project the presentation, please? Next slide, please. Yes, I want to speak today about the EU instrumental in financial instrument, the LIFE program. As you might know, the LIFE program constitutes 100% contribution to the objective and target of the European Green Deal. So the European Green Deal is the plan to make the EU economy sustainable, and we can do this by turning climate and environmental challenges into opportunities and making the transition just and inclusive for all. So it's the only EU program 100% dedicated to the environment, nature conservation, and climate action, including clean energy transition. For the current programming period covering 2021-2027, it has a budget of around 5.4 billion. It is clear that the LIFE program cannot solve all the environmental problems on its own. Other actors are needed, and we are well aware of that. But LIFE occupies a niche between the EU program for research and innovation and the large development programs. As such, it's tried to bridge the gap between research and implementation at large scale, and also involve a great deal of work on testing and demonstrating solutions. So we are now currently implementing the multi-annual work program covering 2021-2024 that was adopted by the European Commission on the 9th of July 2021. We can move to the next slide, please. One of the topics that the sub-program Circular Economy and Quality of Life is covering is the topic of noise. So under this topic, we are giving priority to projects taking place in urban areas in order to maximize the positive impact on a maximum number of persons. What type of project we are looking for here? So we are looking for projects aiming at substantial reductions inside densely populated urban area through solutions with high environmental and economic sustainability. For example, using low surface and or tires And also, for example, those projects working on the low height barrier with low landscape impact and eco-friendly material. And also lowering noise from different sources, not only road, but also railway traffic or airports. So this is the topic of noise, and I show here today because we are willing to have projects covering this topic. We can go to the next slide, on the last one, please. And so, are you having a good idea in mind? If you are having a good idea of mind, the upcoming call for proposal will be published on the 18th of April 2024 within the tendering and the funding and tenders portal of the European Commission. And between 23 and 26 of April, we will have the info day on the program, where all the calls for proposal will be explained, and we will go through carefully to all of them. So, and here the links to the live YouTube channel where you can see the info day from the previous year. But here my main message is that if you have a good idea covering the topic of noise, now is the time. We will publish the call on the 18th of April, and it will be remained open for at least 4 months. So this is from my side. I wish you a very successful and fruitful meeting, and we can move ahead. Now the floor is yours, Marco.
Yeah, thank you, Manuel. For everybody, and I know already the people rightfully got motivated on the chat, we have Slido to post your questions. So what is the idea here? With Slido, can you please post the slide with the QR code? Yeah. Yes, well, okay. So we have Slido, and you would ask your question through Slido. You are welcome to vote also the question that others may have posed, so that we identify what are the topics that are most of interest for you. And then this question will be passed on to through the moderators onto the speakers along the day. So there is no possibility to ask direct questions on the chat, but definitely there is a team of people working in the background, and they will select the questions, and they will try to merge them if there are many, so that that we can move on. And they will post the question for the moderators online. So use Slido, and this set, take a QR code, make a screenshot, take your mobile phone next to you, be ready, because then I think that it is more or less 9:15, and I will be ready to kick with the first presentation. The first presentation is the one from Fabienne. So here we go. Thank you, Fabienne. I would like to spend 1 minute of introduction. Fabienne Anfosso-Ledée is a senior researcher at Université Gustave Eiffel in France. And over more than 25 years, she developed tools for assessing road traffic noise, tire road noise emission, and quiet road surfaces properties. In 2009-2010, at the European Commission Joint Research Center, which is a technical arm of the European Commission, she continued to develop the harmonized noise prediction method CNOSOS-U, which is a methodology to calculate the noise level also on the road, and now part of the Environmental Noise Directive. In France, she chairs the National Group on Road Noise Characteristics. She is active in standardization within the ISO and the CEN groups. Fabienne, thank you for your participation today. We are glad that you are here with us today, and we are all ready to listen your interesting first presentation. Fabienne, the floor is yours.
Okay, thank you very much, Marco, for this presentation. So it will be my pleasure to start this session and set the scene in terms of legislation and standardization regarding low noise road surfaces. Yes, you can. So I will present you the overview of low noise pavement legislation and standards. Next, please. In my talk, I will first address the background of low noise pavement, briefly to set the scene, and then I will go a little more in details into the current situation of the legislation. I will also introduce the guidelines that are been developed for integrating noise in road management, and in particular 2 documents that I think are really relevant. I will say some words about the standardization works, but this will be completed a little later by Manfred Heider, and then the conclusion. So next, please. To set the background, then the first thing is low noise pavement were developed and tested a long time ago. It seems that it started in the early 1980s, where the first porous pavement and low noise pavements were tested and implemented, probably in the Netherlands first, but also in France, Germany, United Kingdom, and a little later over the years in other countries. And in some of them, it's the implementation or the first trial sections are a little more recent. So this sketch, it comes from an inquiry that was made within the FERL, which is the Forum of European National Highway Research Laboratories, and that was done in 2023. So this exists for a long time, so you should think that we have a long experience on this. So next, please. An additional thing is that there were over the last 20 years and since the early 2000, many EU and national projects to address the development of these low noise pavement development. So it could be in terms of developing very efficient products to lay on the roads to reduce noise, to optimize their properties, but it's also to check the implementation, to test it, and to address the technical policies on how to implement these low noise surfaces in the policies or in the technical guidelines or legal documents. So there was many projects that contributed to make some progress in this development, and we will have some overviews in the next presentations. So next slide, please. So over all these projects and the work that has been done, and together with the road manufacturer, there has been the development of pavement products that were very successful in bringing significant noise reduction of the noise emitted by the road traffic. And this is mainly road surfaces with fine, what we call the texture, the surface texture, that can be obtained with very small aggregates. So I'm a little technical, but it appears that it's very efficient. And it's also mainly products with porosity, where air void content in it, that brings some additional effect to reduce noise emission and to bring some sound absorption. So most of the low noise products have fine texture and porosity inside. Here you have some examples of surfaces. There are other surfaces, of course, but these surfaces can bring what I call significant noise reduction, means 3, 4, 5, 6 dBs or maybe more with regard to standard standard road surfaces or rough surfaces. But of course, the noise reduction will depend on what was the initial situation before implementing these surfaces. So next, please. But we must admit that low noise pavements are still insufficiently used in practice in most EU countries. There are some exceptions, of course, countries like in the Netherlands, where something like 90 or 95% of the highway network is covered with porous asphalt, or countries like Austria, where it's supposed to be around 40 or 50% of the network, or so in Germany, where you have more than 700 kilometers porous asphalt on the network. But in most other countries, although either it's unknown how many kilometers of low noise surface have been laid down, or you have only few sections smaller than 50 kilometers long, or just trial sections. So there is a real question on why is it still insufficiently laid in practice. So next, please. The main issue, we had an inquiry in France to investigate on this question some years ago, where we asked to the 90 road managers in total, why do you have are you so reluctant in using low noise pavement? And they all said that, well, first, it's a lack of durability of performance. We have no guarantees on that. So when I say durability of performance, it's both mechanical performance and also acoustical performance. Second is the additional cost, in particular, because if you have to have specific maintenance, then it's expensive. So there's no guarantee on how much it will cost. And the third item that was mentioned is the lack of regulatory and normative framework. And the lack of standard and reference procedure for comparing pavement is an obstacle for sharing experience with others or other countries or other road managers, and then to further develop low noise pavement. So this is one of the important topics that I will address now. Next, please. What is the current situation in terms of legislation? So there is no, we must say that there is no specific EU legislation on low noise pavement, as there would be for vehicles or for tires, for instance. There are some guidelines that I will present a little after that at EU level for road planning and maintenance. So that is an important first step. But one of the main issues is in Europe, there is no common definition of what is a low noise pavement. In some countries, it's a specific type of road surface, like for instance, SMA, porous asphalt or thin layer. So this is what is addressed as a low noise pavement. In other countries, it's defined in terms of a maximum noise emission level or tire road noise emission level. But not all of them mention the same measuring method for that or the same reference speed. So the levels are quite diverse in what is expressed in the countries. Or a third possibility is to define a low noise pavement in terms of a minimum noise reduction with regard to a reference pavement. But here again, there is not a consensus on the reference pavement, and not all the countries have the same reference pavement. So this makes it very complex to exchange information, data, and things like that. Next, please. There are some countries where a reference framework exists. We made an inquiry in the frame of the CEN, which is the European Standardization Committee, in the working group 5 for road surfaces properties. We made an inquiry and within 13 countries, and some of them said, no, we have no specific requirement or scheme for requirement for low noise pavement. Some of the countries said, we have some informal guidelines, but the road owner do as they feel if they want to introduce low noise surfaces. In some other countries, and in the majority of the countries who answered, they mentioned that they have some formal documents, formal guidelines, or even regulations. This is the case for Czech Republic, UK, for instance, where there is a complete set. In some countries, it's just a formal document, like in Lithuania or Flemish, in Belgium. And probably the most advanced system can be found in Austria or in Germany, where they have guidelines for noise protection on roads and technical test regulations for the correction values of the emission from road surfaces. And also, I will not forget in the Netherlands, where there is what is called the CVEC method, where that determines road correction factors for certain types of pavement and products. And they also have guidelines for the test of checking the conformity, the compliance of the products when they are laid. I also indicated some acronyms that you can see, and this refers to the test method that are used in these regulations and guidelines. So you see mostly CPX, SPB. I will just explain what it is after, but this is referring to the noise measuring method, and you can see that it's not the same method in all the cases. You have mainly two types of methods, so it makes it difficult to compare this legislation and to have a bright idea of what is the advantage or drawback of such legislation, and to have a consensus on that. But anyway, this gives probably good guides if one day we want to go for a common regulation on that. Next, please. An additional thing I wanted to mention in terms of legislation is, of course, the EU noise directive, which ask the member states to calculate some strategic noise maps, and also to make some noise action plans. And in this noise directive, in the calculation of road traffic noise emission, then there is this introduction of road surface effects with regard to a virtual reference pavement that, okay, it's an average, it corresponds to an average of a dense asphalt concrete and a SMA concrete, but it comes from a large database where we average all the results and said, oh, okay, this is the virtual reference pavement. And from this situation, then we express some default, some correction factors. And the Knossos EU scheme describe how to give some default correction values that come from typical Dutch pavements and Dutch database. But the member states can also calculate or derive their own correction factors corresponding to their road surface. So here we can connect the legislation on the road surfaces itself, on the works, and the environmental effect of these road surfaces. And also low noise pavements are very often used in as a noise reduction solution in noise action plans that are part of this EU noise directive. Next, please. Okay, so I told you that there is no EU directive on low noise pavement directly, but there are some guidelines, and I would mention two guidelines. The first one is the CEDAR technical report drafted in 2017. CEDAR is a conference of European road directorates, and they propose two possible approaches for integrating noise in road planning, and they discuss the pros and cons. So You can either specify a pavement type like SMA 8 or porous asphalt, and without control after application, you can either set national systems of labeling with no control applications, or you can introduce values requirements like noise reduction criteria or noise reduction criteria in tendering for initial noise, or even better, you can also set some requirements for long time behavior of low noise surfaces. Next, please. The other guidelines important is the EU Green Public Procurement that has been revised in 2016. And these guidelines set minimum requirements for low noise pavement design, setting some values of noise emission, maximum values of noise emission. They also, the interesting thing is that these guidelines specify also criteria for durability of performance, with allowing some 3 dB noise increase after 5 years laying. And also another particularity is that they set 2-level criteria according to the wish of the road manager. There are core criteria or comprehensive criteria that are more requiring, with minor 3 dB requirements more. Next, please.
Fabienne, can you speed up a bit?
Yes, I'm just finishing with standards. So just recalling that, what about standard? There are 2 standardized methods for measuring. This is only measuring standards. So it explains how to measure tie road noise. You have the SPB, what I called SPB in my previous year, that is a pass-by method. And you have a close proximity CPX method that measures very close to a test tire. So of course, these methods are not directly comparable. It's not the same noise level that you measure, but they can be complementary, and they both have pros and cons. Next, please. Because it's only standardization method, then the CEN decided to draft a standard to explain how to use these measurement standards to really characterize acoustic performance of pavement. So this is a 4-objective standard where you intend to compare, classify pavements to have to set a labeling of products, for instance. The second objective is to check the conformity of production after laying down. So it's very useful for tenders with performance requirement that we want to check. The third objective is explains how to monitor acoustic performance over time, which is very useful to insert data in pavement management systems. And fourth objective, last but not least, is the derivation of the road pavement corrections factor that can be used in the CNOSOS-EU, so European Directive for Strategic Noise Maps. So this is these 4 objectives. Next, please. Currently, this method was derived and tested in a EU project called ROSAN. It is based on measurements with this close proximity method only. And it's now submitted for a ballot, CEN ballot. So it's not yet an official standard. Next, please. So in my conclusion, what I want to insist on is that the successful development of low noise pavement needs a holistic approach, including technical approach, development of measuring tool, assessing tool, and also regulatory and standardized method to explain how to implement this method and how to implement the road surfaces. There are some technical issues that still need to be solved for low noise surfaces, but they are progress that have been made recently to understand how to develop this surface. A standardization and guidance system for road managers is in progress, and it needs to be finalized and further tested, and experience to be shared. Thank you for your attention. Next one. Yes, thank you for your attention.
And thank you, Fabienne. This was pretty clear. I think that we received a set of questions. I tried to group, because of the time, into 2 mainstream ones. The first one that it is why don't we have an EU regulatory system, the common regulatory system, regulatory framework? What happens there?
I think one of the things is we have to have a common definition first of what is low noise pavement, and we have to agree on how to specify a low noise surface. And once I think it will be a big step when we have this clear in mind, that we share a common view. What is a low noise surface?
Yeah, but is it a technical problem, like, you know, the method then, or is it more a political problem of agreeing which one you select?
Maybe a bit both, I would say.
Oh, okay, we will continue anyway in the afternoon. I'll go for the second question quickly. We have Umesh Parajuli, apologies for not spelling your name correctly, the senior pavement advisor on national highways in the UK, and I asked that there in UK they have 70% thin surface core system, and they are said to be low noise surfacing, but they are causing negative texture and voided, which allow water to penetrate inside and later causing early failure or surfacing durability issue. What will be the solution for this issue? Or maybe do we take it for later for our presentation? I don't know.
I don't know. There are some issues with the low noise pavement, and the one that was mentioned is correct. But we also have some solutions, and it needs specific attention, and that maybe the people who lay down the surfaces are not used to have this kind of specific attention. And clearly, you have to have a very good support and to have a very good conditions when you lay that down, and you also have to have specific maintenance in winter of the surface. But yes, the porosity, the air void contents create problems.
And thank you for mentioning the winter, because indeed we have another question, a question from Pavlos. And it says, okay, north of Europe, south of Europe, do we have the same, like, can we have a common EU legal framework to define low noise road surfaces, north to south?
So I'm not sure I understood well. Do you mean that in the legal?
Can you have the same legal framework, like the same standard for the north and for the south, or maybe it depends. You know, it depends. You define it differently because of meteorological reasons, because of the use of the surface. Mainly south of north, I think he has in mind a difference in meteorological.
Yes, that could be a point. But if you introduce two kinds of legislation, one for the north, one for the south, then it will prevent, I think, a good consensus and good share of experience. There are some winter maintenance specifics for these low noise surfaces. That's true, but you have winter maintenance problems also in many countries, not only in the north. But I don't say no legislation with the north and south. I've never seen that.
Clear. I think the message is clear. Fabienne, we thank you very much. We move on to our next presentation, and there we have Bert, Peeters, and Ronald van Loon. It's the right paper. Yeah. So Bert Peeters is a senior consultant and engineer at M+P in the Netherlands, and since 2003 his main expertise is in noise and vibration from transport, road, rail traffic, and aviation. Him and his colleagues are M+P are good in performing noise measurements and calculation, and in policy and legislation. They have a history of more than 40 years in developing and testing low noise pavements, and also in urban areas. M+P is active in the Netherlands and as well in European research centers, such as in the NEMO project. And Ronald van Loon has been a senior consultant at M+P in the Netherlands since 1999. His main expertise is in the field of noise and vibration from transport, and he specializes in tire noise and low noise pavements. He and his colleagues were involved in many projects for road builders, road authorities, and environmental services in the Netherlands. M+P conducts a lot of research into acoustic aging of low-noise road surfaces, and these results are included in the national acoustic calculation schemes. He and his colleagues at M+P are good at carrying out noise measurement and calculation and at policy and legislation. M+P is active, once again, both in the Netherlands and European research projects such as the NEMO one. And today, we will have exceptionally both of these two fantastic experts talking and presenting us what are the lessons learned from low noise pavement in urban areas. Bert and then Ronald, thank you for being here with us. The floor is yours.
Great. Thank you, Marco, and thank you for the invitation. It's a great pleasure to and welcome everybody. Good morning. It's a great pleasure to talk to all of you this morning about low noise pavements, which has been well, our favorite subject for many years. If you could start the presentation, please. We will be talking about lessons learned not only in the recent NEMO project, but also in the, well, as Marco said, the 40 years that we have behind us now. And I will start with, so it's about urban areas, but I will start with motorways first, and then Ronald will take over when we go to more urban area applications. Next slide, please. So we start with Dutch motorways. As Fabienne said, we have a lot of porous asphalt, low noise pavements in our Dutch motorways. And so the situation is slightly different than in urban areas, because on motorways we have high speeds, we have little acceleration, we have little sharp turns, so we have low tangential or horizontal forces, which is good for porous pavements because they are slightly more vulnerable to these kind of forces. We also have these motorways are wide roads, so we have rain in the Netherlands, so we need to get rid of the water somehow. So water drainage is important, especially for these motorways. And also, well, as everywhere in Europe, we have increased traffic and as well as housing. People need to live somewhere, and the Netherlands is a dense country. You have more and more people living close to the motorway, so we need to manage the noise. And a solution for all of this is that what we have in the Netherlands is porous asphalt. Next slide, please. So a little bit of physics here. Why is porous asphalt a low noise pavement? Well, one thing is sound absorption. So the pores in the voids between the stones are able to trap or absorb some of the sound emitted by the tires. And why this is particularly effective is because of this horn effect, as I shown it on the left. So actually this horn shape between the tire and the road actually amplifies very much the noise that is generated by the tires. So it's up to 15 decibels of amplification due to this geometrical shape. And you can imagine that if you make the road surface sound absorbing, it's like cutting away half of the horn, which makes this amplification much less efficient. So that could reduce up to 6 dB or more in terms of noise reduction by a sound absorbing pavement. And then the other important thing is, as Fabienne already mentioned, the surface texture. So this is the roughness of the road surface. You can imagine if you have larger stones on the surface, then this will cause more tire vibrations and thus more noise. So that's why in the Netherlands, well, once we discovered that porous asphalt works well, there have been several developments into even more low noise porous asphalt surfaces using double layers. So we use a top layer of also porous stones, but much smaller stones. So there we have the combination of both porosity and sound absorption combined with small stones, and there's a fine texture causing less tire vibrations. And these smaller stones are also good for rolling resistance and like a fuel consumption, which I'll get to later. So we have porous layer asphalt on our single layer porous asphalt on our roads. We have double layer porous asphalt, and we have double layer with even smaller stones, fine graded double layer, which is what we use on our national roads. Next slide, please. So here, as Fabienne said, especially on our motorways, we have lots and lots of this porous asphalt, and we have to give some credit to our National Road Authority, who have been very committed to getting all of our national roads more quiet, and who have been willing to invest also money, of course, in doing this. So by now, everything you see on the map, everything that is blue or green is low noise pavement. So it's single layer porous asphalt, or in blue, a double layer porous asphalt, or even some more silent pavements. And if you look at the graph on the left, there you will see that in 1995 we had no porous pavements on our national motorways, and now 30 years later we have porous asphalt on up to more than 90% of our national roads, of which 1/3 is extra low noise, these double layer porous asphalts. Next slide, please. So I think this shows clearly that at least for motorways, this can be done. I mean, porous asphalt are a standard in the Netherlands now. I put for these particular surfaces some numbers here. So as somebody mentioned, porous pavements are more prone to durability issues because of water and winter conditions, etc. So that is true. I mean, porous surfaces need to be replaced more often than dense surfaces, but it can be done. So as this shows here, so dense asphalt concrete is our reference here, which has a lifetime of 12 to 18 years, and here 12 years is the outer lane where the trucks drive, and 18 years is the left lanes where the cars drive, right? So the trucks cause more damage, of course, than lighter vehicles. If you go to single layer porous asphalt, the lifetime is close to this. Actually, it's not so much worse than dense asphalt concretes. And actually, we need to give some credit also to the Dutch road contractors who have been with us for the last 30 years in developing and laying these surfaces, who have become very good at it. So if anybody wonders how to pave such a pavement, then please talk to the Dutch. Double layer porous asphalt is slightly more prone to durability issues, which has a shorter lifetime of, say, 9 to 13 years or 8 to 12 years for the fine graded porous asphalt, which is shorter but still manageable. It's not 2 years, right? So you have to replace the surface every 8 years on the outer lane and every 12 years on the left lane. Yes, but this is merely a cost issue and not so much a maintenance issue, I think. So if you're willing to invest, every noise measure costs money, so also these surfaces. Okay, costs for single layer porous asphalt are relatively not so high. It's actually quite a cheap product. Double layer porous asphalt is slightly more, not slightly, it's more expensive. But if you're willing to invest this, then it's available. And the noise reduction is up to 60 dB. And to be clear, next slide, please. These are noise reductions that are averaged over the lifetime of the surface. So we're not looking at merely new porous asphalt, but as an average over the new and the old pavements. Next slide, please. And this was actually confirmed by the RIVM in a recent report. So in the Dutch calculation method, we use lifetime average correction factors in our calculations, not new asphalt, not noise reductions for new asphalt, but lifetime average values. And RIVM has confirmed in a report actually 2 weeks ago, where they have done measurements on 44 locations with pavements of all ages all along a motorway, that the average noise reduction that they measure with a CPX-like measurement is actually comparable to what we use in our calculations as a lifetime average value. So this was, a good conclusion, I think, that we do use accurate correction values. Okay, I will give the floor to Ronald to talk about urban areas. Next slide, please.
Yes. Okay, as Bert mentioned, since the 90s, the porous asphalt was frequently used in the main road network, but it was not suitable for the urban use. So porous asphalt is more vulnerable to damages due to acceleration, braking, and cornering. And at the same time, there is a great need for quiet road surfaces in the built-up environment. So the Dutch government stimulated the application of low noise road surfaces on urban and regional roads by contributing to the costs for construction and maintenance. And the road manager was required to implement a monitoring program on that road section, what is laid with and the costs were contributed by the government. There were 3 types of quiet road surfaces involved into the program, and it was the thin surface layer. You see it on the left on the slide, the low noise paving blocks for the low speed areas, and there was also the 2-layered porous asphalt. And the thin surface layers became very popular and were widely used on as a road surface. Asphalt producers and road authorities started experimenting with this quite new thin surface layers. These are finely graded mixtures for good surface texture and has less porosity than the porous asphalt. But the noise reduction was still quite well. Next slide, please. Yes, we have done a study at these thin surface layers, and therefore we made a selection of 31 locations in the Netherlands, and we selected them with the following conditions. First of all, we want locations where we have do the investigations until 8 years after laying, and the locations are a distribution of different road builders, locations with variation of traffic loads, and locations throughout all the Netherlands. And the measurement program was carried out with a combination of the SPB and the CPX method mentioned by Fabienne. You can see below when the measurements were performed. We have a SPB and CPX measurement at for the initial situation. And we repeated the CPX measurements after 2, 5, 8, and 11 years. Next slide, please. In that study, we found 2 important conclusions. Firstly, we gained insight to the technical lifespan of the thin surface layers. And about 60% of the test sections were still in use after 8 years. But on the other hand, you can see 15% had also been replaced after 5 years. And questionnaires among road authorities showed that stone loss and leveling were the main reasons for replacement, and the road surfaces in question often had a high porosity level up to 20%, and that might be the reason for the earlier replacements. The second conclusion of the investigation was that the average noise reduction over the lifetime was about 3 to 4 decibels relative to the Dutch reference values that represents a dense asphalt concrete. Next slide, please. And after these experiences, there was still a need for more durable road surfaces with replacement cycles of 12 years. And a lower noise reduction than 4 decibels was acceptable in many cases. And the road authorities want to be able to use larger road section lengths. The thin surface layers were seen more as a solution for single hotspots with serious noise problems. And this is how the acoustically optimized SMA was born. This is an SMA 8 with stone size 8 with a slightly higher cavity. The porosity is up to 8 to 9%. And at the moment, we can say that it's used on many regional roads, and that we also see it now in the urban environments. Okay, next slide, please. In 2020, we started with a consortium of 18 partners with the NEMO project. It was a project funded by the European Union in the Horizon 2020 program. And one of the outlines was the development of an asphalt solutions to reduce not only noise, but also gaseous and particle emissions. And the challenge was to come up with an asphalt that not only reduced noise, but had also no negative effects on the gas fumes. And additionally, we proposed the idea of using porous asphalt as a buffer for microplastics. Road and tire wear particles will be collected and retained in the pores of the asphalt. And microplastics from tire wear are seen by the European Union as a major environmental problem at the moment. Next slide, please. Yes, in 3 years, we have gone step by step from an asphalt design to test pieces in the laboratory, and finally to test sections on the proving ground of the University of Gustave Eiffel in Nantes. And in Nantes, the fatigue tests were carried out, and the usage period of 20 years of heavy traffic was simulated. Next slide, please. Yes, the NEMO project resulted in a road surface that fits urban applications. This is noise reducing. This is noise reducing and has low rolling resistance, and can withstand traffic movements in urban traffic. And the second asphalt design suits the peri-urban circumstances and has a capacity to collect tire road wear particles in the porous structure. Okay, next slide, please. And in the end of the project, the urban asphalt mixtures is laid on the test section in Florence. And the first results in Florence shows a noise reduction of 3 decibels to a relative to a newly laid standard pavement there on the same road. And on the right, you see the initial experiments we have been carried out, where we try to detect the trapped tire road wear particles via XRT or CT scans from asphalt cores taken from the proving ground. Okay, I give the floor to Bert.
Yes,
Yep.
you have one slide with conclusions. Next slide, please. So I think, as we have seen, low noise road surfaces have been a successful measure on Dutch motorways for 20+ years. I think this is clear. And actually, it's not only on motorways. I think it's important that we also focus on urban areas, because this is, in terms of policy and impact, this is where most of the people live, right? So as we've seen, also for more than 20 years, we have been experimenting in the Netherlands, developing low noise pavements also for urban areas. And I think we can conclude that these are more prone to durability issues. So that's why the contractors are focusing now on slightly less porosity and more texture optimization for these urban areas. And well, an example of what is done currently the state of the art is this NEMO project that we've recently been doing, and which has delivered, I think, good services that have been applied and tested. Okay, so I think we have good experience with low noise pavements, but I think what's important, if you look to the future, is that also low noise pavement development needs to keep up with modern time. And this is not only about the world is not only about noise. I think the whole world is busy with climate change and raw materials, etc. So the research that we see now going on in the Netherlands is more focused also on these issues. So can we construct a new porous pavement from an old porous pavement? Can we do horizontal recycling, and can we do it in a circular way? And also energy consumption. So this is energy consumption when laying or destroying these surfaces, but also the energy consumption from the traffic actually driving over these roads. So then we're talking about rolling resistance and fuel consumption, which are also important aspects. And then, as Ronald mentioned, tire road wear and microplastics is also something that is important for road pavements. So to manage all of these issues, a couple of years back, we did good efforts from the Netherlands to introduce a road surface label, like we had for the tire label, so you can manage the different aspects that road pavements need to address. Well, this is more or less the stop, but I would be for reintroducing this road surface label and thinking about more aspects than only noise. So I want to give that thought also to the floor for today, and I think that's it for now. Thank you for your attention.
And
yes.
Bert and Ronald, thank you very much indeed. We have a set of questions. I'll go quick. They're taking on the topic, what happens there in the Netherlands. A first question would be, why is in the Netherlands not evolving towards 2-layer porous asphalt?
Yeah.
On the highways, for example.
I think we are actually evolving more and more into 2-layer asphalt instead of single-layer porous asphalt. I think we see more and more of this 2-layer in specific locations where we have noise issues. I do know that maybe the person who asked the question was triggered by my bar chart, where you see a slightly less double-layer porous asphalt over time, which I do not fully understand myself. So I need to go back to our National Road Authority and check where these values come from. But in general, my impression is that we do see more and more double-layer porous asphalt on our roads, which now is about 1/3.
I would like to say, at the same time, there is another question on the same topic. So another colleague say, in the rest of Europe, we are down to 0. So at the same time, we see this as a beautiful experience. So what are the factors that in the Netherlands allow to go for low noise road surfaces?
Yeah. Yeah, so that's the question for policymakers, but I think credits to our National Road Authority who have been doing joining us and putting money aside for research as well as for application of these road noise pavements. As I say, it's mainly a cost issue. If you're willing to invest, then it can happen. It's not a technical issue. It's a money issue, I think. And they have been investing in research together with research institutes, but also with the road contractors. So again, credits to our road contractors in the Netherlands who have been very ambitious and enthusiastic in trying to lay perfect low noise road surface and have been very experienced with this now. So I wish that we could share also some of their knowledge with the rest of Europe somehow. So maybe that's a question for today, how we can do this. We can export this to the rest of Europe.
Yeah, and perhaps one last question from Giacomo Cuciniello. It says, to what traffic levels is the durability mentioned in the presentation related?
Yeah, so in the table that I showed, these values, they are for the averaged over all the Dutch motorways. So this includes road motorways with very heavy traffic. And as I said, the lowest values, so 8 to 12 years. So the 8 years are for the rightmost lane where all the trucks drive. So we know that the truck lane needs more often to be replaced than the left lanes where you have mainly passenger cars. But these are motorway averages. So, and we have quite busy motorways in the Netherlands. Yeah.
Very, very quick, because there is a very last question. I ask you to reply quickly, but then we will move to the next presentation. And it is asking, sorry, here it is. How about the drawbacks in winter maintenance of the salting for porous asphalt?
Okay.
Yeah, we do salting in the Netherlands in winter conditions, and I really see no issues. No, well, we do see, of course, that on some locations we do have also problems with winter issues. So, but it's not so much related to salting, I think. No, I think this can be done, and it works fine. Yeah.
Okay, then I have a very last one. Sorry, the last one is changing from 16 to 8 macro texture and friction at high speed undergo changes, and how do you manage?
Yeah, I noticed this question. I think we have no issues with safety with these AA, even with the fine and graded AA porous asphalt, which has 6 mm stones, which is even, I think we see no issues with safety. We see no increase in accidents because of, no. For motorways, please, no. Maybe one, sorry.
It's also the porous asphalt is also better in rainy conditions. So yeah. It's for the safety. You can also say it's an advantage. Yeah, it's an advantage, and yeah, we have a lot of rain in the Netherlands. There are other countries with a lot of rain, and yeah, in that condition, you have a safer road surface.
It's always a pleasure to drive from Belgium back into the Netherlands on these when it rains, right? So it's,
we will all come to the Netherlands to enjoy these beautiful, quiet, and safe road pavements. And thank you very much, Bert. Thank you very much, Ronald.
Thank you. So now we move to the next presentation, and the presentation will be given by Giulia Custodi. Dr. Custodi is a project manager of the LIFE project that I know quite well because I have the pleasure to be the project advisor. Named LIFE Cold and Low Noise Asphalt that was recently finished and implemented in the city of Paris. Giulia holds a PhD in urban and gender study, and she's in charge of the strategy for reduction of the light pollution. So very upcoming topic, Giulia, I think. Former project manager in an urban agency focused on gender mainstreaming. So the interdisciplinary of her academic and professional status allow her to have a wide vision about the complexity of the ecological transition where we are all now, so which links all Mr. Custodi interests. So Giulia, the floor is yours, and we are very much looking forward to hear the experience of these 3 asphalt formulas that you have been testing in the city of Paris. Thank you.
Thank you very much, Manuel. So I stop my video and I will start directly for the slide number 3. So the Cool and Low Noise Asphalt project is co-financed by the European Union as part of the Life Fund and the City of Paris, and it benefits from a partnership with the Technical Evaluation Center for the Sound Environment in Île-de-France, Bruit Paris, the Colas and Eurovia companies that made the formulation of the asphalts, and the University Paris-Cité, the laboratory of Tomorrow Energy. It aimed to reduce noise from road traffic in the city, in particular rolling noise, and to reduce the intensity of UHI by developing innovative formulas for bituminous coatings, which have phonic and thermal properties while maintaining a good mechanical durability. Next slide, please. To do this, we tested 3 new bituminous road surfaces on the 3 Parisian pilot sites, and the project started in 2017, and in 2018 we had the production of the 3 formula and the inauguration in October of the same year, and from 2019 to 2022 we had the noise and thermal surveys, the campaign, the measurement campaigns. The project ended in 2023, and now we are in the afterlife period of the project that is dedicated mostly to the dissemination and sensibilization on this formulation of this innovative pavements. So next slide. For the formulation of the asphalt mixes, Eurovia developed the Puma for Euro les Courbes, and this innovative formula was carried out on Puma asphalt pavement, and the mechanical studies was carried out on the Puma bonding coat asphalt complex in order to solve the constraints of the pilot site, and because there was an implementation of a thin layer of coated material than the Puma coating without reworking the foundation in this case. Next slide. Colas company developed 2 bituminous formulation by optimizing classic formulation, adding new performances on acoustic level, durability, and reduction of UHA effects and all the 3 formulation. So next slide, please. Has had a controlled cost. From an economic point of view, the maximal additional cost compared to the reference does not exceed 10% in any of the 3 cases. So you can see the 3 pilot sites and the innovative asphalts has been deployed on 200 meters for each road section, and 200 meters are the reference zone, and we put a traditional new coat to compare the 3 formula. So next slide. For the methodologies that we used for the thermal measurements, we relied on the existence of a non-potable water network, and the project enabled the implementation of an experimental protocol for watering streets during hot days, and each portion of the street was equipped with a weather station that measured the thermal control comfort of pedestrians. And for the watering, we had to weight the heat wave in Paris, and the criteria corresponds to a minimum temperature above 21 degrees and a maximum temperature above 31 on average over 3 consecutive days. and the protocol started according to the weather forecast. Next slide. For the acoustic measurement methodologies, we had the two types of acoustic measurements. The first aimed to compare sound levels on building facades between innovative and reference covering. These are continuous measurements that have been subjected on an annual reports. And the second is directly related to the noise of the tire on the road, the CPX measurements. And this is an acoustic acquisition system installed on an electric car. And these are one-off measurements carried out once a year during the night. And their goal is to know the intrinsic performances of the coating and follow their evolution over several years. Next slide. We had during this period of measuring, we wanted to listen to Parisians, and we installed for the autumn 2021 and 2022 3 stands on each road to meet the residents of the district affected by the experience and to inform everyone on the results of the measurements at midterm at the end. Next slide. One important action was this a survey form that was distributed in 2021 to gather more widely the feelings of people in the sector. So we asked to residents, but also traders and users of public spaces. And their feedback was strongly positive, with several testimonies of a perception of improvement in the quality of the environment. Next, please. For the results, for the thermal results, we had intermediate results showed an interesting trend, reducing the temperature felt at the sidewalk level. However, the consolidated conclusion of the study in June 2023 showed that the coatings have not achieved the hoped for results. In fact, next slide. The socio-economic impacts of the thermal results has shown that this impact of this watering of the streets are extremely low. And they do not compensate for the initial investment, most of all the use of water that do not justify the importance of this result, the use of this resource. Next slide. Anyway, there are other way to use watering in the town, the cities, because traditionally the street watering has been used in many ways to improve thermal comfort during the heat waves. Next slide. For the acoustic results, on the opposite, the phonic aspects of these innovative materials have shown their very effective characteristics, and the results show that maintenance of a reduction in sound level associated with a thyroid contact noise over the night period it was very interesting. Next slide. So we in the first slide we had the measure of the facade noise, and in the second slide we have the CPX results, and we have to note that the reduction in sound levels is greatest at night when single vehicle pass, higher speeds and other sources of noise are reduced, such as works, human activity, etc. There is anyway a significantly faster deterioration in the acoustic performances of the innovative coatings than the standard solution in 2020 observed in 2022, except for the Puma, whose performances appears stable over time. Next slide. For the results of the socioeconomic impacts of the acoustic aspects. Based on the results observed on the reduction in nighttime noise level linked to the testing of new coatings, the benefit generated for the Parisian population in terms of health and economic impact can be quantified in the case of an application to a part or all of Parisian roads with experienced coatings. So the evaluation takes into account the main economic factors such as health, discomfort and disruption of sleep, economic, loss of productivity that is now available. And these costs are compared to the average cost of use and maintenance of innovative solutions compared to the conventional road surfaces. For instance, for the 15 kilometers our Paris road network, if we treated just this part, the saving made by innovative mixes at mostly the SMA phone and the BB Phone Plus, compared with standard mixes, are in order of the 34 millions after 5 years, with the extra costs recovered in the first year. Next slide. If the entire Paris road network is treated, the saving would be in the order of 400 million after 5 years. And this is why it's important to monitor and to continue to monitor the acoustic performances after the end of the project, because it will provide a socioeconomic assessment over a period of 10 years. For the next slide, again, for slide from the maintain of the afterlife action is for us very important, and the city of Paris, all the partnership, Colas and Eurovia and Bruit Paris, we are all committed to continue the monitoring on the acoustic performance. So we have all the measurements continue at least one per year, and some missions will be carried out every 2.5 years. Next slide. And we have also, of course, continuing the performance monitoring and the communication planning to spread this information on this project. Next slide. Thank you for your attention.
Thank you so much, Giulia, for your presentation. So now we have like a few minutes for a couple of questions. And the first one is this one, Giulia. So there is someone asking that 63% of the respondents note a reduction of road noise, as just 23% of them consider it is important. Why a reduction of noise by 3 decibels is not considered as important? I think that is related with the, how the project was. You targeted more, and then you reduce only in one case 2 decibels and another one 3. So maybe that is the reason why you did consider.
I cannot see. I cannot say why. Maybe it's the problem of just 200 meters of implementation, because the portion was very just for the very little zone. So I think it is important on the feelings of people, because 100 meters you walk away really fast. But for the residents, they were really aware of the change. So maybe for the pedestrian is different.
And that related also to that, to where you deploy this 200 linear meter of the asphalt that you have been testing. There is a question coming from Giacomo Cuciniello, is the following one. How large is the contribution of rolling noise to the whole traffic noise in such a crowded network with traffic, light, intersection, stop and go mode traffic?
That's why we focus our analysis on the night, because it's where when other activities are less important, and we can really perceive a benefit for people. We had to say also that yes, in Paris there camion distribution of a delivery service and other things that make the city really nice, but we have, and it is something that I didn't mention in the presentation, but these asphalts are now used on all the renewal of the Parisian roads for the future. So I think our survey and our analysis can spread to other sites, and not just on the 3 pilot sites for the next 5 years. And this is something we can monitor better, I think.
You have been elaborated on that, Giulia, already, but there is a question Pablos is asking is the following. Is there a logic base on which the Paris municipality decides to go for the low nose road surface? So what is the reason? I think that what is the reason behind that the Paris city is going through that? Is it pushed by the citizen? Is a decision that the public authority, or how is it?
We have some level of reduction noise. We have a policy, some plans to reduce the noise, and we have levels of to attend of reduction of noise in next years. So that's an important choice of the municipality, and of course. It's something in Paris that it's very visible, the noise, and it's really important to reduce. Also, I will say that is interesting in an economic point of view, because the choice to not exceed 10% made these solutions really available for the renewal of the streets in Paris.
Thank you so much, Giulia. I think that now we are ready to move to the next presentation. Thank you so much, Giulia.
Thank you. Thank you very much.
And now we move to the next slide, and will be the colleague Patrizia Bellucci. So I want to briefly introduce you, Patrizia. Patrizia Bellucci is a renowned figure in acoustic and research, educated at the University of Rome with a master in electronics and a PhD in technical physics. Her career has primarily been with ANAS. ANAS is the Italy's road infrastructure agency. As a head of the research and development, she gave her contribution in the field of acoustic by leading national and European research projects, including the recent founded project Live Silent, a project that I know. I don't have the pleasure to be the project advisor, Patrizia, but it's a project that I've been involved in the evaluation and I know quite well. So, Patrizia, the floor is yours, and we are here to listen to you. Thank you.
Thank you very much, and good morning, everyone. So, presentation, thank you. So in this presentation, I'm going to talk about Anna's experience on the use of low noise pavement. Next slide, please. And let's start with a brief introduction to the National Road Network in Italy. The National Road Network is managed by ANAS, and it spans over 32,000 kilometers of roads, including 939 kilometers of motorway. According to the Environmental Noise Directive, roads with a traffic flow exceeding 3 million of vehicles per year must be noise mapped. And this required ANAS to map nearly 10,000 kilometers of roads. The results of these mapping activities have led to the identification of approximately 8,000 sites in need of being reclaimed. Among these, 2,338 kilometers can be rehabilitated using low noise pavement. And this is applicable not only in areas where the exceedance of noise limits is minimal, but also in situations where the use of low noise pavement can help contain the size and cost of more impactful solutions, such as noise barrier. Next slide, please. So the opportunity of implementing low noise pavement is also reflected in a recent draft of a new decree on minimum environmental criteria, which requires road owners and managers to adopt low noise pavement on the primary road network, as well as on roads of other categories where noise mitigation measures must be implemented. Specifically, this decree states that in case of construction of new roads, but also in case of maintenance or adaptation of existing roads, low noise pavement must be used to contain rolling noise. And to this end, the mixture must ensure an acoustic emission level lower than the limits reported in this slide, which depends on the speed limit assigned to each road category. Besides, these results must be guaranteed without modifying the mechanical and functional performance of the pavement. Next slide, please. This decree also promotes the use of sustainable and recycled materials, including end-of-life tires in road infrastructures through a series of environmental criteria and sustainable construction techniques. In this slide are reported the main points introduced by the decree, including the minimum or recommended performance as a criterion for awarding design services and execution of construction, maintenance, and updating works of road infrastructures. This decree also encourages the use of recycled materials, along with guidance on their use by providing technical specification to ease the implementation on construction sites. Particular emphasis is also given to the service life of low noise pavement to reduce their cost. Next slide, please. So, having established the need of using low noise pavement, the question now is what kind of low noise pavement? And to answer this question, in 2019, ANAS decided to undertake an experimental investigation to compare 3 types of pavement which are most commonly used in Italy. These are an experimental wearing course with optimized texture, a wearing course with crown rubber achieved with a wet process, and a wearing course containing crown rubber achieved with a dry process. And these mixtures were compared to a type B reference wearing course that is extensively used by ANAS. And specifically, the optimized texture is a road surface engineered to provide enhanced performance characteristics, acting mainly on a careful design of aggregate gradation. The wet technology is instead a process which involves a mixture of crown rubber with bitumen to obtain an elastomeric bituminous mastic. And the dry technology, on the other hand, is a process in which crown rubber is combined with aggregates along with filler, bitumen, and other possible additives. Next slide, please. After 6 months, the acoustic characteristics of these surfaces were measured, and the results, unfortunately, were rather disappointing, as you can see from this slide. And the measured noise level differed by about 1 dB from those detected on the reference pavement. And as you can also see, the most effective type appeared to be the road stretch made using the dry process. However, as we have shown earlier, And as it is known and said, that in the long run, the difference will increase due to the lower mechanical impedance and the longer durability of rubberized low noise pavement. Next slide, please. So let's see now some which are the strengths of this kind of pavement. First of all, the service life, which depends on various factors, including environmental condition, traffic volumes, and type. Then the reduction of carbon dioxide emission by 30%, only if the life cycle exceeds the expected 3 years duration of conventional pavement. And we can't forget the elimination of waste from landfill. Just to give you a number, a road 1 kilometer long and approximately 7 meters wide allows for the recycling of 1,000 tires, which corresponds to a weight of about 7 to 10 tons. What about cost? The initial cost is higher, but offset by the longer lifespan of the pavement and the reduced maintenance required. In this slide, you can also see a table reporting the main performance indicators, namely cost index, durability, and noise reduction, the latter reported in a qualitative way. Next, please. So using this information, it is possible to provide a preliminary cost-benefit analysis based on the performance indicators reporting in this slide. First of all, the durability, which is a key factor in maximizing the benefit-cost ratio, because more durable pavements require less maintenance and have a longer lifespan. Then the cost, a lower cost index may indicate an initial saving, but as said before, it is necessary to balance this saving with the durability and long-term performance of the pavement. And finally, the environmental parameters, first of all, the acoustic properties, which are significant benefit, especially in urban or residential areas, as well as the reduction of carbon dioxide in the environment and the recycling of end-of-life tires. Therefore, considering all these aspects, the technology that appears to achieve the highest cost-benefit ratio is the hybrid dry technology. Next slide, please. Rubberized low noise pavement are very interesting from many perspectives, but however, they also have some drawbacks, some critical aspects related to the emission of unhealthy substances, such as polycyclic aromatic hydrocarbons, which are released when laying down the rubberized pavement. They show higher concentration compared to conventional pavement, as you can see from this graph. In the purple bar is referred to the dry process, the red one to the wet process, and the yellow one to the reference surface. Furthermore, measurement of volatile organic compounds have also shown values higher than the background levels. So this highlights the need to carry out further study, especially in the field of epidemiology, and also to establish threshold values which are not currently set in Italy. Next slide, please. So this line outlines the efforts to promote rubberized pavements in Italy, and highlights the various experimental test sites and studies carried out over the years. Since 2011, Italy has been engaged in several research projects with the aim to explore the use of crown rubber from end-of-life tires for road pavements. So far, 680 kilometers have been repaved using crown rubber from end-of-life tires. These implementations were mainly carried out in the northern parts of Italy, but always as part of experimental trials. The most recent initiative is the European Lifestyle Project, which began in September 2023 under the guidance and coordination of ANAS. Next slide, please. So the Life Island project fits into this context and aims to develop and implement in a real-test site a sustainable and eco-friendly solution, including low noise pavement, to mitigate noise in complex urban environment where road and railway noise sources coexist. This project has two main challenges. The first one is to manage noise mitigation measures in a coordinated and synergistic way in order to achieve more effective and efficient results, and also to support the implementation of noise mitigation measures at the source. Next slide, please. So following these challenges, the Lifestyle project pursues three main objectives. The first one is to increase the service life of low noise pavement to reduce bed costs. So the focus is on the durability of low noise pavement. The second one is to improve the acoustic, structural, and safety performance of low-high noise barriers through the design and validation of an innovative product. And in this case, the effort is to find an effective solution to mitigate railway noise at the source. And finally, the third objective is to define procedures to manage and implement noise mitigation measures in complex environmental scenarios. Next slide, please. In this slide is described the methodological approach used for achieve the two above mentioned solution. As for the low noise pavement, the idea is to increase the service life of the pavement by about 20%, corresponding to a cost reduction by 13%. This will be achieved by mixing functionalized cellulose fibers achieved from recycled cardboard to pram rubber and modified bitumen. As for low-high noise barriers, also this solution will be made using a recycled material, but in this case, we will adopt an innovative approach based on metamaterials. Next slide, please. So the third objective will be pursued by developing and testing an operational methodology to support the coordination and implementation of noise mitigation measures of various nature and type to ensure the integration of the envisaged solution and optimal results, both in terms of effectiveness and efficiency. Next slide, please. So in conclusion, the acoustic mapping and action plans developed by ANAS have highlighted the need for an extensive use of a source-based solution, and not only in areas where the exceedance of noise limits is minimal, but also in situations where the use of low noise pavement can help reduce the size and cost of more impactful solutions such as noise barriers. This approach is also reflected in the recent draft of a new decree on minimum environmental criteria, which requires infrastructure managers and owners to adopt low noise pavement, even on roads where noise mitigation measures are not necessary. To meet these requirements, ANAS has carried out a measurement campaign to verify the performance of some types of low noise pavement, particularly those containing pram rubber from end-of-life tires. The experiment conducted so far, unfortunately, were not satisfactory, and this is the reason why ANAS is keeping on experimenting new solutions. The Lifestyle project fits into this context and aims not only to develop a durable solution, but also to provide operational procedures to enhance noise mitigation in complex environments. And it is because the solution to the noise problem does not lie in the extensive use as a single solution, but in the implementation of a holistic approach where various noise mitigation measures integrate synergistically to achieve the desired and hopefully optimal results. Next slide. Thank you very much for your kind attention.
Thank you so much, Patricia, for this clear presentation. We are having a lot of questions and we take note of them, and then we will try to address also later on during the second section of in the agenda. But now I can pose you a few questions, Patricia, that they are very interesting and relevant. So the first question is, there are a lot of roads in the Netherlands with low noise pavement, not so many in Italy. Why? Can you please explain what are the reasons behind, or what are the main reasons?
Well, the main reason is always the cost. The initial cost of this pavement is very high with respect to conventional pavement. So this is one of the reasons. The other one is the threat of unhealthy emission when laying down the low-noise pavement. So these are the two main reasons why we don't implement low-noise pavements.
But Patricia, sorry, I want to clarify, because I think for the audience is interested, you give some numbers when you say very high cost. What is the proportion? If I pay 100, the standard one, what will it cost?
I'm not sure, but I think 20–30% more.
And related to this, Patricia, our colleague Bert Peter is asking, what about circularity? So can asphalt with added tire rubber be recycled the same way as the other ones, on the standard one, as a regular asphalt?
I didn't catch the question.
So you were presented, Patricia, that you were using an asphalt where you add old tires. So yes. The question is, can asphalt with added tire rubber be recycled on the same way as the regular one?
Yes. Yes, can be recycled. Yes.
So you carry out like life cycle analysis, and there is no any environmental problem.
Well, we are going to evaluate these aspects in our lifestyle project. I don't have any information on this matter now. I'm sorry.
Yeah. Another question is: Are the minimum environmental criteria presented by ANAS mandatory?
Yes. Yes, they are not yet, but they will be mandatory in a few time. Briefly.
So the public authorities are planning to take these criteria, those criteria as mandatory.
It's a new decree that is going to be published in a few time, I suppose.
Okay, I think that maybe we can go to the last question. And the last question is, what is the takeaway between this tested non-porous road in Italy and the porous road in the Netherlands? On noise, on other factors?
I don't know. I can't answer the question. Maybe Filippo, that is our expert in this matter, can reply to this question, but I don't know. I'm sorry.
Okay. Okay, then I think that that's all. We can maybe move to the last presentation of this first section of the day. Gives you the floor, Marco, to present on the speaker.
Yeah, thank you very much. Now we are going for the presentation on standardization of acoustic assessment of low noise pavement from Manfred Heider. Manfred Heider is a senior research engineer for acoustics and transport infrastructure research at the Austrian Institute of Technology in Vienna. And he works in the field of traffic noise, low noise pavements, performance characteristics of noise barriers, and environmental impact of road traffic. He coordinated the Rosanne EU project, where low noise pavements were a major topic, and currently is the convener of the CEN Technical Committee 227, Working Group 5, on pavement surface characteristics. We are glad to have him today to talk and continue the discussion we started with Patricia on specific characteristics of the road pavement. Thank you to be with us this morning. Manfred, the floor is yours.
Thank you. So I would like to continue some of the topics we've already heard about with a special focus on the acoustic assessment of low noise pavements. Next slide, please. So we will start with some background information and then go to some specifics on tire road noise and low noise pavements. And the main focus will be on the assessment methods and how they are currently standardized and how they could be linked to noise mapping in the future. Next slide, please. So the traffic noise as such is a very important environmental cause. It's basically the second most important cause of ill health after air pollution. And the road transport is and it's basically the most significant contributor to environmental noise pollution in the EU. And you probably know that there are the typical effects: annoyance, heart disease, sleep disturbance, also learning impairment. And there are plans in place to reduce the number of people chronically disturbed by noise from transport. Also, there is a very important framework, the European Environmental Noise Directive, first implemented in 2002. And in the meantime, this has done a lot to harmonize noise mapping and action planning. If low noise pavements should contribute to these ends, to the reduction of overall noise from our road, and especially generated in the interaction between road vehicles and road pavements. The results from measurements, from assessment, has to go into the noise mapping, into the action planning. And the Knossos U basically results were then basis for the noise calculation methods that have in the meantime been harmonized. And there is a section and there are tables in the method that directly address this influence of pavements. So it's important to assess the pavements to be able to include this into the planning for this to have an actual effect overall. Next slide, please. There are some sources of exterior road traffic noise, some of which can be influenced by low noise pavements and some of which cannot be. So there's clearly probably the easiest and most recognizable, at least in the past, is engine and powertrain noise of internal combustion engine motors. This is definitely dominant, or has been dominant in the past, at least for low speeds. But as we are moving to electric vehicles, this is going to more and more fade into the background. It's still dominant for two-wheelers. It's still probably more, will be around longer for heavy vehicles. But this is something with the development of vehicle technology. This is also already very quiet for very developed ICE engines, and will be mostly gone for electric vehicles. So this means that other sources of noise will become more dominant. Then, of course, at the tire road noise, coming from the interaction of the tires with the pavement, is dominant over a wide range of speeds. This here is given 30 to 130 kilometers per hour. So this is basically the noise that in many situations is the one that we have to worry about. And this will remain the case for electric vehicles because they are still tires, they are still touching the surface. So this will be the main noise source in the future, below something like 130. Above that, you will have a contribution of aerodynamic noise at very high speeds, or if you have some superstructures that create noise. But this is probably also where you will not have too many vehicles traveling in the future. So tire road noise will become more important in the future. And this is luckily something also we can influence both with tires and with the pavement. Next slide, please. So also something that you immediately think about, okay, what about making the tires less noisy? So there are regulations in place and limits, even international ones, that regulate the tires. You have a tire is a very complex engineering product with a lot of features like tread pattern with dimensions, hardness, tires, also the number of tires you have on a vehicle. All of these can be worked with and can lead to a certain reduction. But of course, the tire also has to keep you on the pavement. So there's a certain friction needed. You don't want too much rolling resistance to basically reduce your fuel consumption. So all this has to be met together with the noise reduction that the tire can provide. So there have definitely been advances in this, but of course there are also some limitations on what you can do with the tire. Also, there's a big difference between tires and pavements. These are very different products. Tires are basically an international market. They have a compared to pavements, a much shorter product life. They something like 3 to 5 years, and basically then you have new types of tires. If you move to the next slide, pavements are of course usually more likely installed by national road administrations. They have lifetimes usually measured in decades, and this means this is a different market, and these are different. There are also different ways to influence this. A lot of research has been done on how to achieve low noise pavements. We've seen some examples before. You want to have small maximum aggregate sizes on the top, sufficient texture depth, ideally something like you would call a plateau with valleys, so that you do not have too much vibration excitation. You would like to have void content so that any compressed air can escape, and ideally even sound absorption. So a lot of pavement technologies try to use at least some of these features to achieve low noise. And as we have seen, it's very successful. But of course, these are usually still in many countries still not the standard types of pavements, and you have to always also to look how does this impact other properties of the pavement and also the lifetime. Okay, next slide, please. So yes, as I said, very prominent example, of course, porous asphalt, 1 or 2 layers, where you have also the effect of a significant sound absorption. In other countries where basically you have more an issue with winter maintenance, also low noise domestic asphalt is very popular, and in general any kind of asphalt type with low aggregate sizes on top. Then also concrete is popular because of very high durability, very long lifetimes. For example, exposed aggregate concrete or longitudinally grooved or grinded concrete. And there are also some more experimental pavements like the poroelastic pavements, where we have seen that you can get into a problem with durability. But there's I would say a good toolbox already to choose from. Next slide, please. So you want to know and you want to know reliably how these pavements perform. Usually compared to some national reference and ideally also with comparable measurement methods. So there are, and any assessment, any also derivation of emission factors usually relies on one of these 2 groups of methods that I will introduce here. One of them are the pass-by methods. So the ISO 11819-1, standardized by ISO, is the so-called statistical pass-by method with some variants. So basically you measure a vehicle pass-bys, individual vehicle pass-bys at a microphone that's 7.5 meters from the center of the lane at 1.2 or 3 meter height, and you do a regression analysis over speed to determine the noise level for a reference speed. So this is a point measurement. You get information information about something like 50 to 100 meter of a pavement. You have to have suitable traffic flow, which can be quite challenging because you need to have isolated vehicle pass by. This means not too many and not too few vehicles. And you should also avoid large reflecting surfaces and things like guardrails and noise barriers. And currently noise barriers are, at least for example in Austria, they're very often to be found. So it's sometimes hard to find places where you can measure this. You can do this with normal traffic, then it's called SPB, or control pass by, then it's done with dedicated vehicles. And you can also include this is something called a backing board to basically get rid at least of some of the reflections. Next slide, please. The other large group, I would say, are the trailer-based methods. Most of them following a variant of ISO 111819-2, the close proximity method, where you go very close to the tire road contact. You use a special vehicle or trailer with a reference test tire that is supposed to represent the usual tires that you have on the road. Of course, a single tire can only do so much in this, and you also have a tire that is at least acoustically similar to heavy vehicles. So the requirements here for CPX are, I would say, much lower, and you can do this in traffic speed. You can do this over long distances. Which of course is also the reason why we have seen a lot of CPX values in the previous presentations. So, but these are two complementary and the main methods that you will use for getting an idea how your pavement performs. Next slide, please. Here is some comparison, as I already mentioned. The advantage of SBB is you have the overall vehicle noise, not only tire road noise. You have a good representation of heavy vehicles, but it's of course limited to a spot, and you have relatively high requirements. For the CPX method, you basically can go arbitrary lengths, but you only measure the tire road contact noise. So this is basically what gives you some limitation. Also, it's a somewhat more limited frequency range. Next slide, please. We looked at this in the Roseanne project, and also there were a lot of measurements and improvements done, especially on the CPX methods. And the idea from this project was to have something to hand over to standardization. And this is the result of this project has then been worked on in Working Group 5 and in Working Group 33. Working Group 33 of ISO covers the measurement methods as such. And in Working Group 5, we are working to using these methods to develop procedures for different applications. Next slide, please. Yes, this is just a listing, so for future reference, if you want to see where exactly what topic is worked on. Next slide. Next slide, please. This is the key basically what you apply these methods for. So main application, the easiest application, of course, to compare two different pavements, basically using the same method, using the same standard to see what is the difference, which one is better, to have a ranking. Then, of course, if you already have more experience, you can do acceptance or conformity testing of low noise pavements. Does your low noise pavement really get you the performance that you need? And ideally, you should also do long-term or network level monitoring of this acoustics. And basically, the probably most challenging part is also then really to derive noise emission parameters that can be used in noise mapping from these measurements. But these are different applications which also require different use of these measurement methods. Also different, for example, number of repetitions and requirements. So that's not usually one-to-one one of these measurement methods. Next slide, please. So the point where it all comes together are the common noise calculation methods used for noise mapping, as I already mentioned. There is a table of pavement-specific emission parameters. This is not an all-exhaustive table, and currently does not cover all the pavements used in the EU. So ideally, the pavement-specific parameters should also be derived from a standardized measurement procedure, and this is something that's currently the hot topic also in standardization. Next slide, please. I think that's also my final slide. So as we've seen, low noise pavements are a key tool for road traffic noise abatement. And the tire road noise will become more important in the future, especially with electric vehicles. We have currently standardized assessment methods that allow an acoustic characterization, but they cover different aspects of road traffic noise. And this is necessary for noise mapping. So basically, to really have an overall comparison, basically you need a standardized derivation of these parameters from noise mapping from measurements. And then basically you go with the same set or the same type of parameters, of course, with different values, into the noise mapping. Okay, thank you. And I hope this quick overview of the topic was useful to you.
Thank you, Manfred. I can absolutely confirm it was very useful. I think personally, I like very much this table where you presented, you highlighted the pros and the cons of the two basic different methodologies. And the first question is on this topic. The first question we have for you is it better to test a road with statistical pass-by or with close proximity method? The floor is yours.
Thank you. That's actually a question we're asking ourselves all the time. No, basically, it depends. It depends on what you want to do. If you want to really link to noise mapping, then most countries usually tend to use some kind of SBB, because that's usually the more traditionally go basically from noise propagation from the tire to the roadside. That's basically where you measure, and then basically you project this farther on. This has the advantage, as I said, of a wider frequency range. Usually you want to be able to go from something like 60 hertz to up to 8,000 hertz in the calculation. If you really want to do approval testing or also long distance monitoring, it's very hard to do this with SBB. This is something where you go with CPX. And if you also really want to get a quick impression, I think there is also a good database of CPX data usually available. So this is probably something that you go first. If you go for a new development of a pavement, I would actually do both, because it really tells you a complementary story, and usually need both sides of the story.
And as a follow-up question, we are talking about the new vehicles, the electric vehicles, but also the widening of the vehicles. So I would combine two questions here, where they say, is the widening of the vehicles making a difference? And then the follow-up, I anticipate it will be on tires and electric vehicles. So what happens, are these methods still relevant for tires and new electric vehicles? So first, the width of the new vehicles, they're getting larger and larger.
Yes, getting larger, that does not, I would say that does not change this the applicability of the methods in principle. It's basically what you look at is the lane, and you more or less attribute a value. In the end, you have an emission line, and this is something you want to attribute a value to. So what changes a little bit is of course where exactly the tires sit on the road, but you also have a natural variation anyway. So this is not a rail, it's a road. So basically this will probably not have too much of an influence. Second point, of course, as I said, if you go electric, you eliminate basically this lower part of the noise versus speed curve to a high extent. So much more of the tire road noise becomes visible in the measurements at lower speeds. Of course, there is some countervailing effect, as at least below 20 kilometers per hour, there's currently a requirement also to have some signaling to avoid for safety. So at this point, you still have another noise source. But something between 20 and 50, you will definitely see more of a tire road noise effect than you had before.
Oh yeah, indeed. I can compliment that our colleagues are in Geneva today and tomorrow exactly to discuss the added noise level and an added noise to the electric vehicles. And there's I can inform you to reply to the colleague, but everybody that there are discussions ongoing on if and to what extent we should allow these new vehicles to add noise. So the low speed. At low speed, they would be allowed to reach 75 decibels at 2 meters, which is roughly 67 at the 7.5 meter from the center of the road. This said, there's another question on different set of coefficient and national version of the Knossos method. The Knossos, no, I repeat for everybody, is the methodology that was developed in the European Union to calculate noise level. So these CPICs and SPB methods could be useful to derive national values, but is it realistic to replace by a single set of EU values?
Currently, there is also, I would say, not a single set of EU values in the regulation that we have in the sorry, I think it's the directive. We have a set of values that are based, I would say, a lot on the experience in the Netherlands. So that's very good to have a good starting point. In the implementation of the European Noise Directive, also many other countries have started to derive their values because they have seen that they do not have exactly the same pavements. This is already going on. This is going on the basis of different approaches. You can do this from some existing parameters using calculations. You can do new measurements. If basically you will not have one set of parameters, but if you have a system where you can really qualify the pavement so that you have a setup of parameters that works with the noise calculation method of the END, I think that is definitely feasible. But of course, this has to be clearly defined so that everybody plays by the same rules. But the mechanism is there. I would say not the values are not there for every pavement that's currently in use in the EU.
Yeah, thank you. Manfred, there is a highly voted question. I don't know how much it is for you. Probably it is for many of the speakers this morning. But I will try to anticipate to you, and definitely we will be back on this question in the afternoon. Because it's a broad question, and it is a question that could be appropriate for you, for Patricia, for Giulia. It's the combustion engine vehicles, they make noise at low speed, but with the uptake of the electric vehicle, maybe the low noise road surfaces, they are relevant also for low speeds in the city centers. And so why still not to consider the low noise road surfaces for city centers? Maybe do you have, from your perspective so far, experiences in how much is the contribution from the road side if we have electric vehicles that do not add extra noise? Can you give us some insight?
Currently, we speaking from Austria, we currently do not have the percentages of electric vehicles that you can really have a good data on this at the moment. When you speak with road managers in cities, they have they are open to the topic, but on the other hand, they have very reliable, useful pavements, relatively standard pavements that they currently use. And in the city, there's a lot of disruption usually also going on off the surface. You have manholes, you have probably more frequent repair, also changes in the pavement. So even a very good low noise pavement may not stay that way if you have a lot of changes in the pavement or roadworks going on. So this is probably one concern. And of course, currently with still a high percentage of internal combustion engines, there is maybe not yet the urge so much to move to low noise pavements. I think they are open to it. They're trying to experiment with this for a rollout on a large scale. Currently, I would say they are at the moment a bit hesitant still.
Manfred, stay with us. It was foreseen for you, but somehow it's nice, you know, that the people, you know, the participants really wanted to discuss it 30 kilometers an hour. So please stay there. I see Bert, he would like to maybe make a statement, and Giulia make a statement. We are opening it up. It wasn't foreseen, but it's nice. Go on. Bert.
Thank you, Marco. I'm taking advantage of what we're going to do this afternoon. I wanted to reflect on the Knossos question. I think there are two things. So if we talk about a EU-wide harmonization of correction factors, then we should also have a EU-wide definition of the reference surface. And how are we going to? So the reference surface is also different in different countries. That's what I noticed in what we've been doing the last couple of years. That's one thing. And the second thing, I really look forward and I really promote the fact that we now have upcoming a CEN standard on this, so that we can at least do it in a standardized way in all European countries. I think this is very relevant. But I would like to stress that, especially for if we want to develop road surface corrections for national noise assessment methods, we should go for the most accurate method that we have available, which in my opinion would be the SPB method. So I think the standard should include also SPB. That's as a start for the discussion maybe this afternoon.
Yeah. So maybe Giulia, you wanted to intervene on the 30 kilometers an hour and electric vehicle.
Yes, but really, because in our project, the measurement to with the CPX car, that is an electric car. So our measurements are already on test on 50 kilometers and on 30 kilometers per hour, because our experiment is in the city center. So we, in our experience, we showed that it is possible, that it is useful to decrease the level of noise. So yes, it's really interesting also for the city center.
Thank you very much. Very interesting perspective. And Manfred, perhaps let's go back for a second on the topic of your presentation. It was on standardization, and I allow myself to ask a question from me. Can you expand on why is this standardization somehow this process getting so slow and not being used that much? So we see Bert mentioning that, you know, we still have different reference surfaces, and we have two methods. I'm still a bit puzzled. So can you clarify, where do we go? Why not a single standardization process? What are the perspectives?
Yes. So basically, I think it's good that the standardization process on this is ongoing, and then that we have a Europe-wide discussion in the framework of CEN. I think that's an achievement. It's of course not that quickly going, not that as quickly going as we probably had anticipated. And the reason is that as we've seen, there are many nationally already quite developed systems which have reference surfaces, which or not, which use different methods to derive the parameters, and also built partially also in different stages of development, I would say. So definitely the Netherlands is probably very far developed in this. Others are starting or somewhere midway, and not all of them have gone into the same direction. So really getting everybody to agree on a common set. I think on the level of the basic measurement methods, this is relatively clear. So almost everybody accepts that there is CPX, there is SPB. There are still some technical points that you can discuss about, but the measurement method as such are very well accepted. But how to use them to derive the emission values and which ones are the most appropriate, this has been also tied to some, I would say, national history, and also systems which are on top of that. This is, of course, a little bit more difficult than to things like changing, for example, the tire pressure in the CPX tire. This is definitely the point where we will have and are.
Then I want to tease you. Now, yes. Be honest. Is the people, do the people refrain from going for a single method because they are pretty much attached to their own method, or are there through technical barriers, through technical reasons that prevent from going one direction or the other? And I see Fabienne may also add on this. So first, Manfred.
I think it's not so much technical. As I say, agreement on the basic methods is very widespread. I think it's really agreeing, which is still a technical topic, on how to go from these to the actual parameters and how they fit into a system where you can make prediction at the end about the emission at some resident in the end. The European Noise Directive and the need to do noise mapping in a consistent way has already created a lot of push into the right direction, I would say. But there are still also countries which use a little bit different system for local projects. So this has not been uniform, and of course this creates a pull also in a little bit different direction. But yeah, probably it's not a non-technical issue, but it's already moved relatively far from the purely technical realm, I would say.
So I see space for the European Commission to play its role. Okay. Fabienne, one quick sentence from your side before we thank Manfred and we go for the coffee. Fabienne.
Oh, yes. Okay. Yeah, thank you. I just wanted to mention that standardization takes time because it's based on consensus. And so we need this discussion, and we need to convince, we need to exchange data, we need to compare, we need to discuss, and this takes time, a lot of time. And even for the measurement method, it took nearly 20 years to have this CPX method standardized. I must just remind that we were discussing about these test tires for very, very long time. And of course, having data needs money, needs time, needs like things like that.
Okay, thank you very much, Fabienne. And I would like to thank, in this case, above all, Manfred for his presentation. I hope it will not take you 20 years to grab your cup of coffee, because now it's night time, isn't it? Here in Brussels, we have a nice cafeteria. We cannot invite you all, but we are sure that you have an opportunity at home. And Manuel, we'll see each other at
11:30 sharp, please.
Brussels time.
We have time, yes. Brussels time. So we have the time for a cup of coffee or tea or stretch our legs, and we will be back at 11:30. Thank you so much.
See you in 13 minutes. Oh, dear colleagues, we are preparing for the start of the next session. Before we start the next session, I would like to anticipate that I understand a number of you would have liked to ask questions, and the idea is that because we will not have time to address all the questions, we will first of all collect them and try to assemble them for this afternoon discussions. But if not, you can send them to the functional mailbox env noise. I will type it in the chat. And through these functional labels, then we will redirect them to the panelists, to the one more appropriate, so that we can come back to you and reply this specific question. And we will create this channel so that you can interact also after this webinar with the people. So I will post this in the chat. We start, and then you will see that in the meanwhile, I will post this functional email address in the chat. We are ready to start with the first panel discussion. The panel discussion will be first composed of an introduction, a quite a substantial introduction, just to motivate you on the topic and to provide you some basic input on the topic itself. And then we will have some time for discussion, for an open discussion with all the presenters and the panelists of today on the screen. And we will gather and try to address as many questions as we can from your side. By this, I would like to thank Professor Filippo Gianmaria Praticò. Professor Praticò had a degree in civil engineering from the Pisa University in Italy, and then a PhD in transportation infrastructure from the Palermo University, again in Italy. After his industrial occupation, he became associate professor in 2002 at the Mediterranean University. Then he was habilitated in full in 2012 and is serving as deputy of the master school, the deputy of the DMET department. He is director of the road laboratory and member of the TRB of US National Academies. He is enlisted in the world ranking top 2% scientists from Stanford University. We are glad to have Filippo with us. Thank you, Filippo, to be with us today. And Filippo will, first of all, have a short introduction. We will then move on with the discussion. Filippo, thank you. The floor is yours.
Thank you, Marco. Thank you, Manuel. Yes, you can see in the first slide of the presentation. It is a pleasure to attend and to be speaker at this webinar. And my presentation, please go to the next slide, is going to focus the following main topics. Dealing about the noise issue and perspectives in terms of many concurring instances. After we will focus on the design and the production of low noise surfaces. And after we will focus on possible discrepancies or antinomies between pavement performance, such as noises versus texture, noises versus friction, and noises versus rolling resistance. Finally, we will focus on possible solutions in terms of an holistic approach to deal with so many performances. Next slide, please. So this day we are focusing on noise, but noise is not the only property of a friction cords or a wearing cords. For sure, we need to talk about the friction. We need to talk about other functional properties such as tunability. We need to talk about surface texture, and there are the mechanistic, the true mechanistic performance, such as the modulus of the fatigue life and so on. Please go ahead with the next slide. So the main concurring parameters are as follows. With friction, basically it is a dimensional rush between two forces. We have the texture, and we are talking about the deviations from a plane. We have the mechanistic properties, And so we are talking about, for example, the modulus, we are talking about the mechanical impedance and so on. The rolling resistance, which is another force, and the rolling resistance coefficient, which is the ratio between two forces, the traction force over the weight of the car. And finally, we have the noise and its fundamental ways to express this pressure, for example, in terms of the well-known van der Pol equation, where we have a first term which focuses on the direct wave, and the second term where the reflection is considered. Go ahead, please, with the next slide. So we are going to talk about noise, but we need to face also the fact that the noise is a vibration, a mechanical vibration in the air, but close to the surfaces there are the same phenomena, but in the bodies. So we are going to talk about vibrations. And overall, we could talk about very well-known solutions or tailored solutions. And in this case, three main principles are given. I mean, working on the acoustical absorption, working on the texture, and maybe working on other effects such as the hardness or the mechanical impedance of the surface. Please go ahead with the next slide. From a methodological standpoint, when we talk about rolling noise, we talk about essentially an interface, a tire pavement interface. And usually, as we saw before, we are going to talk about the statistical pass-by method, the cost-by method, the close proximity method to measure this impact. I don't know if it is so comprehensive to talk about noise by referring only to the loudness or by referring only to the close proximity index, in the sense that there are many psychoacoustics, many psychoacoustic parameters such as the loudness, the sharpness, the roughness, the fluctuation strengths to consider, such as listening to a piece of Brahms or Mozart. We will be fascinated by the pitch, the duration, the timbre, and the texture of the sound. Go ahead with the next slide, please. So we are going to consider in the beginning complex scenarios. Go ahead, please, with the slide. Complex scenarios such as the one that we are considering in the project Life Sneak, or the ones that we are considering in the project Life Silent. Patrizia Bellucci this morning talking about this new project. And we are dealing with the near field or far field context, and we are dealing with ground-borne vibrations. We are dealing with the primary body waves. We are dealing with Rayleigh propagation of waves, and we are dealing with secondary body waves. And finally, in the interface, we are going to deal with the superposition between the acoustic impact of the vibrations and the acoustic impact of the red car you can see in the picture. Go ahead, please. So when we focus just on vibrations as a sort of mother of the acoustic impact in the interface, we will deal with frequencies, damping, transmissibility, and resonance transmissibility. Go ahead, please. And if we consider, such as in the Life Silent project, the superposition between the track noise and the tire pavement noise, we will need to focus on the particular wavelength that is concerned. So the transition from a Hertzian spring functioning towards a sprung mass functioning. Go ahead, please. And particularly by referring to the interaction tire versus pavement, we will deal with the pavement excitation. Go ahead, please. So in generation, in propagation, and at the receiver, we could deal with diverse mitigation methods. Go ahead, please. Now, let's focus on designing and constructing quiet asphalt concretes. As we said before, we could adopt known solutions. We could have a multi-purpose design, which means dealing with noise, but dealing also with friction, with rolling noise, with rolling resistance and so on. And if we focus just on noise, we can approach the problem in terms of optimization of the texture, in terms of optimization of the acoustic absorption, or in terms of the optimization of the hardness of the surface. Go ahead, please. If we make reference to known solution, we will have a lot of references in the literature, including the well-known text book after Sandberg and Egismond. Go ahead, please. Go ahead with the next slide, please. Okay, I'm going to continue, but I don't see the next slide. So we can focus through the literature on different solutions, such as, for example, the thin surfaces, such as, for example, the Marco, something is wrong in the sense that the slides are not moving.
Yeah, Filippo,
okay,
I apologize for that. I think you wanted to see this interesting table, isn't it? And
yes.
Yeah, the reference for adopting known solution. And I really invite you to explain this table thoroughly, because I think it's extremely useful for the people to understand what the technologies nowadays allow, which is the scope of your presentation, to guide us through the technological aspects of having low noise road surfaces. Thank you, Filippo. Go ahead.
So, coming again to the strategy of using known solutions, that means that you don't need to design the mixture. You can find a lot of information in the literature. For example, asphalt rubberized friction courses, open graded friction courses, common hot mix asphalts, a lot of diverse expressions in the field of dense graded friction courses and open graded OG friction courses. Particularly, each type of well-known solution can be adapted and optimized in order to minimize the acoustic indicators, such as the cross proximity index. So each solution, among the ones, this solution you are now seeing, are solutions that have pros and contras. I mean, just talking about noise. You need to consider the performance in terms of acoustic performance at the beginning, but you need to consider also the performance over time. And now the concept from this discussion, another important concept emerges: the durability of the performance. I mean, each performance of the payment has a certain durability, and the durability is, roughly speaking, the number of years during which this particular type of payment is working well in the sense of the noise reduction. These decay curves can be analyzed in terms of noise increase per year, and particularly, namely, in terms of decibel increase per year. Now, this table points out that the noise increase per year ranges from 0.5 up to 1.5 per year. This means that the durability, the acoustic durability of several solutions is better. And this is another concept that acts on the previous concept of the acoustic indicator of the S-construct payment. Go ahead, please, with the next slide. So we have seen that there are two main concepts, that is to say, the durability of the acoustic performance and the acoustic performance of the S-constructed payment. But which are the secrets behind the durability and behind the acoustic performance at the beginning? Because this is everything, because if we have algorithms and tools to optimize the noise, we are talking about an engineering standpoint. Now, the main variables we can work on are the grading of the aggregates, the mineralogy of the aggregates, and the shape-related indicators of the aggregates, the quality, the grade, the percentage of bitumen, the quality and quantity of the remaining materials, including, for example, crumb rubber or fibers, the compaction effort, the compaction type, the thickness of the layer, and finally, on the temperatures. So these classes of variables impact the volumetrics and the main acoustic indicators, which are here reported. This is to say, the specific gravity of the bitumen, the specific gravity of the mixture. Specific gravity means, in other terms, air voids. The main factor affecting air voids, such as the theoretical specific gravity, the characteristics related to the aggregates, such as the GSB and GSA, the air voids, and here we are moving towards the acoustical field, the effective air voids, which is a subset of the air voids, the voids in mineral aggregates, the voids filled with asphalt, and the dust proportion. But as far as we refer to the lay down surface, we will need to analyze the surface texture, and so we will talk about the texture level. We will talk about the tortuosity, the resistivity. We will talk about factors that relate to the energy loss of the air when flowing into the pores, and so on. Now, all these indicators are the causes of the main impacts on your right. So functional properties, but at the same time, friction, texture, mechanistic properties, and so on. Please go ahead with the next slide. But what are going to do in the lab in order to design the future mixture? We will need to focus on a certain composition. We will need to mix the components, for example, aggregates, bitumen, clam rubber, and after we will need to compact the samples, and after we will need to focus on acoustic absorption on the samples, airflow resistance on the samples, mechanical impedance on the samples and on site, and so on. Go ahead with the next slide, please. This is the overall picture. So from the mix design with a certain composition through the construction, we are going to have a certain texture and a certain level of compaction. So we are going to have a certain VMA, a certain effective porosity at the beginning of the construction, but over time, as an effect of the traffic volume, we will have a certain decay curve of the permeability, of the friction, of the noise level, and of the remaining properties such as rolling resistance. In the extreme right of the slide, you can have a look to the main instances that the pavement designer need to focus on. So safety, pavement management system, and user costs, agency costs, and externalities. Go ahead, please, with the next slide. If we want a tailored design of the mixture, we need to move from the grading. So we need to understand that the main causes of the noise impact derive from grading and compaction. So we will have in the at the plant a certain number of grading classes, a certain aggregate gradation, and through a certain prediction model, we will have a transition from the aggregate grading to the texture, and through models such as the ENT or other models, we will derive the prediction of the noise based on texture. So finally, the prediction of the output based on what we did in the lab and at the asphalt plant. Go ahead, please. If we focus on mixtures that work on the principle of the acoustic absorption more than on the principle of the texture optimization, we will have to carefully design, to carefully construct, which means we are talking about compaction efforts, and after to carefully validate on site the acoustic absorption, for example, through the quasi-reflectant surfaces to the on-site Kundet tube, and for the remaining types of mixtures through the so-called Adrian method. Go ahead, please. So for porous mixtures, the algorithms build on the mixed design, on the control of the air voids content, of the thickness, on the controls of the remaining acoustic properties, that is to say, resistivity and tortuosity, finally having a certain spectrum of absorption coefficient with a given maximum, usually one single maximum, for example, around 1 kilohertz. Go ahead, please. So the problem will be to design and to control and plan the construction process in order to fit our needs through a given absorption spectrum. So this includes also the maximum of the absorption spectrum. It is to say the prediction of the maximum of the absorption spectrum. Go ahead, please.
Filippo, you have 5 minutes more, then we will open for the discussion.
Okay, so there is no time to go in detail in the discussion of the texture prediction models. Go ahead. There are many prediction models, such as this one and the previous. Go ahead. We are talking about prediction models. This is to say the way to predict the term on your left, that is a noise impact, through the texture and through the volumetrics of the mixture. Go ahead, please. Go ahead, please. We are talking about always the prediction of the noise performance through the texture. Go ahead. Go ahead again, please. And this is one of the results. For example, we are talking about the EVIA project and the low noise friction course in Via Paisiello in Florence. Go ahead, please. A couple of words about the well-known perspective of the hardness of the surface. It seems that mechanical impedance is a good indicator to evaluate the rod response, especially in the range from 400 to 3.2 kilohertz. This is a very well-known and we could see hot topic. This is to say the relationship between the hardness of the pavement surface and the noise impact. Go ahead, please. Minor drawbacks in the design of surfaces. Noise sometimes is not so well correlated with texture, and particularly many speakers this morning talked about the thin friction courses, bitubitumine, remission, and so on. Okay, in these cases, issues may arise because of the texture, the macro texture level. Through the hexagonal packing model, it is possible to derive the several laws and algorithms that can be used. Go ahead, please. For friction, this is another area which is absolutely important in the sense that, yes, usually friction and noise are not in contrast, but if you go more in detail, you will find many types of friction courses in which there is a little bit of antinomy, of of contrast between friction and noise. This is not true. This is not true in general, in the sense that we may have very good friction-related conditions, very good noise-related conditions for several types of friction causes, but it is not always true. Go ahead, please. Go ahead, please. The conclusions are that yes, there are cases in which you can have a very good friction and a very good noise impact. It is to say a very low noise pavement. But another warning derives from paying attention to on-site and implant variability. Because especially for several solutions, the variability linked to the construction process is so high to hinder the low noise friction costs to properly work. Go ahead, please. Go ahead, please. Now, finally, rolling resistance. Rolling resistance is correlated with the surface texture. It is well known. Unfortunately, the higher the texture, the higher the rolling resistance. But, namely, particularly, the higher the texture and the higher the noise too, in the field of macro texture and for several wavelengths. So this is a good news. Rolling resistance and noise can be friend in terms of having a pavement which have a low rolling resistance and low noise. But particularly for the very well-known solutions such as the Peeters, the bad news is that usually the higher the mechanical impedance and the higher the noise, and also vice versa, which is what happens for the Peeters. So we are talking about the Peeters that are a very good solution in terms of noise, but they are not very good solutions often in terms of rolling resistance. Go ahead, please, with the next slide. Rolling resistance for Peeters greatly depends on vehicle mass, but overall, this rolling resistance is higher than from split mass asphalts and lower than for microsurfaces. It is quite simple to understand the rationale behind. The rationale behind is that both noise and rolling resistance are very well correlated with texture, macro texture, I see, but they are not very well correlated with the mechanical impedance. Go ahead, please. So we talked about many performance. Despite the fact that this day is a day vocated to the noise performance, in the design you need to consider safety needs, so friction at least. So one strategy is to consider the durability of each performance over time, and so a sort of multi-purpose design as depicted in this picture. And with this slide, I think that my time expired, and I thank you for your attention.
I think there was a very last slide. It was scrolled very quickly through the screen, and but anyway, that's the last slide was on the main references, and we're happy then to share the presentation afterwards. I think Filippo it was challenging to remember all the formulas that you presented. So I have to confess that myself, I'm a bit confused. And, but I'm sure that all the participants, they understood better than me, and they have interesting questions to start to kick off the discussion, and then we will expand. This is the objective a little bit of this panel discussion to all the other speakers that I invite them to switch on the camera, because perhaps they also have some arguments to contribute to the discussion here. So we start with one question from one panelist, Bert, that was proposing to ask, are international road contractors or road authorities currently exchanging expertise? And should this be facilitated on EU level, for instance, through PIRG, IAPA or CEDAR, which for the people, these are organizations that group the road authorities?
Yeah, because I don't know if there's in the audience today, I don't know if there are many road contractors or people from the asphalt business, maybe not. I heard also, I think it was Fabienne say this morning that the durability of low noise pavements strongly depends on a very, say, precise way of laying the surface. And so I guess that there could be a knowledge exchange between asphalt constructors that could be helpful. But I don't know if this is actually happening, or if it should be.
We can start with Filippo. Filippo, you guided us through all this theory, and certainly you have very good knowledge of the different partners. So what is your experience in that one? You know, is this the knowledge shared amongst these different organizations, or is it really all this knowledge remaining at university level?
Frankly speaking, my personal opinion, not only as a professor, but above all as a consultant, as a person that needs to face what happens in the asphalt plant, my opinion is that we need to improve the relationships and the exchange between the owner of the asphalt plant and the academy and the regulations, in the sense that the variability that the processes carried out at the asphalt plant is very high. And in the sense that the processes, for example, the process to introduce the clam rubber at the mixer level, and the processes need also to be improved, and so there is the need for an effort that involves also constructors, contractors, and road authorities, in the sense that at the moment, in my opinion, the low noise payments are something that it is quite well known in the academia, in several contexts at the European level, but road authorities and above all contractors are to involve more and more.
And I think there is an interesting question of following up on this topic. A colleague asked, do we need standards on the pavement mixtures? And are there any initiative to develop such standards? So we've heard from Fabienne and Manfred, and I think I would like first to get the answer from Filippo, and then looking at Fabienne and Manfred to see the perspective. Because here we're talking about pavement mixture standards. And we talked before about a standardization of the testing of the processes. So how does it work? Filippo, pavement mixtures.
From a practical point of view, if we think to the real world, we need to think to the fact that there is a bid, and the contractor is working on a bid that means also a book of contract specifications. And the Marco and Manuel, the mixture recipes, the job mix formulas are there. So we come back to the same issue. Low noise payments means particular mixtures, and means that the contract specifications of the road agencies need to be modified a little bit in order to include also these mixtures. So Marco and Manuel, there is a political level that is the level at which you decide that that road need to be a low noise road. That is at the political level. After there is the technical level, and at the technical level, we are talking about contract specifications. That is the main opportunity and the main issue. The contract specifications, the bid documents. There is the future.
So you think that we could develop, for instance, at European level, bid specification that enter into the matter of the mixtures and not only the properties after they are paved?
Yes, from a certain standpoint, yes. But the way in which you are talking makes it emerge another important point. That is to say, performance-based specifications versus prescriptions. You know, in practice, in Europe, in many nations, many countries such as Italy, we have a lot of mixture between performance-based and prescription-related specifications. What does it mean? It means that in the performance-related specifications, we say that we want close proximity level lower than 90. And we don't say how to do the mixture. But this is quite impossible in practice, because the contractor doesn't have a research center. He needs to be guided. The other opposite situation is the one in which we say, this is the way in which you are going to do your mixture with this percentage of bitumen, this percentage of aggregates, this process. Sometimes you have this prescription-based approach mixed with several performance-related conditions. So there is a little bit of a mix.
That's a bit of a mix. So I turn my head to Fabienne and Manfred. Anticipated that we see on the screen a set of other interesting questions coming up. So I would ask the panelists to be short in their reply to the point. Fabienne and Manfred, what about the standardization processes at European or international level? Is it anything entering into the mixture, pavement mixture, or are they all referring to the performance of the paved road?
There are some European standards for defining the properties of mixed design. It's the series of EN 13108, and with different parts for different types of pavement, like stone mastic asphalt or thin layers or porous asphalt. So you can refer to that to have mechanical characteristics, but these standards do not describe the acoustic properties, of course. And so that's why we have these two sorts of corpus. Either we prescribe the mixing and refer to these EN standards and have the mixture that we want, but we don't know about the performance, or the performance can be quite variable. We're not sure about the performance in terms of noise. Or the other alternative is that you you require the performance, and then you know what you will have as performance, but you don't know what you will have as a product on the road, because sometimes it's up to the road manufacturers to design the mixture and know what is inside it, and you don't know it. And there are probably some countries that do one type of contracts, and some other countries that have other side. In France, we have on the performance requirement side, and because we also think that it promotes innovation. Whereas if you prescribe the mixed design, then there is no innovation behind.
Manfred, do you agree with this scattered picture?
Yes, basically, there are these two approaches, and there's a lot of standardization going on concerning asphalt mixes. Basically, the whole of working group 1, basically in our technical committee, is dedicated to that. Basically the mix itself gives you, I would say, a certain potential for noise results, probably in a certain range. But as far as it's currently designed, there is still quite some variability when these mixes are put on the ground. And this is definitely a factor which makes it difficult if you just go from the mix. So it's basically the mix plus the laying procedure. One of them is, I would say, much more standardized than the other at the moment. So that's a stage where we get a lot of variability inside. And on the other hand, if we try to characterize pavements, we have these methods that I would say overall work very well. Sometimes it's even the challenge to find out what exactly was laid, because there are also sometimes, for example, we had the topic that, for example, void content was only specified within a certain range. So you can have this at the end of one range, or at the one end of the range, or at the other end of the range, and you get quite different acoustic results. So if you have emission parameters, you need to know exactly which pavement you tied it to. Ideally the mix, and even more ideally, even the laying procedure.
Okay, thank you very much. I follow up on a question from Ablenia Barros. Apologies if I didn't spell it correctly. Is the creation of a standardized method to measure mechanical impedance of asphalt pavement already in discussion? Who wants to answer? No. Fabienne says no. Manfred, no. I see more way,
I don't.
More
I
negative
can answer,
than positive nodding. Yeah.
I can answer the question.
Yes, please.
Saying that no, to my knowledge, there is no work on the standardization of the method for measuring mechanical impedance. It's more in the field of research at the moment.
And I follow up on a previous question, which says, what is the optimized low noise solution surface, coarse asphalt, considering cost, durability, carbon sustainability as a whole? So we go back to the initial topic posed by Bert, and I think here is the time to see Bert again intervening, and then Filippo definitely, who's the master on all these technologies, and tell us, okay, but here we want to go to get to the solution. What is the solution? Bert.
I was just wanted to make a short statement. I think we should not be talking about road contractors. I think we should be talking with the road contractors about these issues. And this was one statement I wanted to make. I was not sure about the question you say about different, I think it's different aspects of asphalt that need to be looked at, integrated. Yes, so why I mentioned the road surface label. I agree that it's not noise alone. We should look into sustainability, circularity, all kind of issues. We cannot develop low noise pavements that do not regard all the other aspects, because they would lose the game, right? This noise is not number one on the priority agenda, let's be clear. So if it's not sustainable, if it's not circular, then we can forget about it, right? So I think these are very important topics.
Yeah, I would agree. In a sense, this is recognizably a complex mix of different topics and different issues. But Filippo, coming back to you, and on this topic, so you guided us through this definition and formula and the mixture and how parameters, and features of these road surfaces interfere one with each other. So would you think that there can be always an optimized low noise surface that that is the right balance between the cost, durability, carbon, and sustainability as a whole?
Each door has its own key. If you are talking about a motorway, we will have high-level needs that will be very, very different from the ones that you will have on a urban road or on a rural road. So my idea is to be road specific. This is the first level. The second level is to make a choice reading all the properties that each type of solution has, and after, at the third level, optimizing the given type of mixture. I'm talking about, for example, if you are in urban context and you think that the best solution for you is a thin surface. At this level, beton bitumineux tremiche or something like that, at this level, you will need to optimize your solution based on the remaining characteristics. So the first level, in my opinion, is that you cannot speak about a sort of a panacea of a solution for every condition. Probably it doesn't exist.
I think, the people, and I understand them, they are asking other questions, they go in the same direction. For instance, Tomasz Malec is asking, are there any works being carried out or planned to standardize production technology and use of quiet surface? So perhaps, in light of what I heard, I can propose that the question is also concerning the right location. So my understanding is that, Filippo, you say it depends on the location, and it depends on the type of traffic, on the use of the road. But once we have the use of the road, if we imagine that we have different type of roads for obvious reason, like it's a highway or it's a 30 kilometers an hour road in the city center, but having these two road types in your mind, can you standardize, or is it still that there are some parameters that are dominant? And for instance, there is a statement from Umesh Parayuli. He says, in the UK, the skid resistance is one of the main requirements of surface course asphalt design, meaning you start from skid resistance and then you see what you can do on the rest. So back to the initial question from Thomas. So can you standardize a production technology even if you then split into the two cases, it's low 30 kilometers an hour or highway?
I think that you can. I think that you can, and roughly speaking, solutions are already in place. If you look at the contract specifications, also to the Italian technical specifications, several solutions for given locations are already in place. For example, the porous layer, or so I think that it is possible to enrich the number of solutions in place in the contract specifications. By referring to the other question, the one related to the friction as the main characteristics. Maybe it is one of the things that emerged from my discussion, in the sense that today we are discussing about the noise, but what are the main concerns of the road agency people? The main concerns refer to the accident, and then to the legal consequences deriving from the accidents. So their main concern is friction at the moment. I don't know if it is this is right or it is wrong. Probably we are talking about a sort of intermediate step when the level of knowledge of the effects of noise will be higher. I mean, behind your shoulder, heart attack, and so on. When it will be, there will be a sort of general consensus about the importance of the noise in terms of human health. At that point, the main concern will be friction, but also noise. So I absolutely agree with the fact that a road with an unsatisfactory friction is not a viable solution. It is just a matter of time and enhancement of laws, of level of knowledge and contract specifications.
Yeah, perhaps I think it's time to look at Patrizia, because Patrizia showed us that they repaved hundreds of kilometers of road, and maybe it's good to know her experience and how did they prioritize amongst the different parameters. And there's also a question in that sense. It's a key, there's anonymous that says key issue is to convince maintenance teams that reduce noise surface type does not result in reduced durability and increased carbon. And, you know, how do you do that? Are the studies? So, Patrizia, in your experience, you are representative of a major road network of thousands of kilometers. How did you decide what to look at first?
So, as already said by Filippo, the main concern is safety. So safety is the main concern, but also we are very interested in noise pollution because we have many sites that must be reclaimed, and that could be rehabilitated using low noise pavements. So we are very convinced that the solution could be low noise pavement in many sites, and what we should think about is now how to reach this goal, how to proceed with the implementation of these low noise pavements. So we need some clear specification to be given to contractors, and also to define some awarding criteria for giving this for providing these solutions.
Okay, Patrizia, that was also pretty clear. I mean, experience from someone who has hands on the topic. And I would like to thank Filippo for the intense training that we assisted today on how do you create a low noise road surface, because looking at the time, it's 12:32, so I think it's time for us to go for lunch. And we will have 1 hour of break, so 12:30 to 1:30. So we are perfectly on time, I would say, 2 minutes beyond schedule. So 1:30, we will reconvene. Stay tuned. We will have other 2 interesting panel discussions where we will have other two presentations. Definitely, we will have space for entering again into the details of your questions. And we will start at 1:30 with a panel discussion 2 on integrating new solution in action plans for noise reduction. So the idea would be, once you can do road noise surfaces, how do you and where do you use them? And then we will have another panel discussion at 2:30 on standardization challenges, where Manfred will lead us. This said, enjoy your lunch, come back at 1:30. I would strongly recommend that you stay connected so that you leave the computer and the connection on. And I'll see you at 13:30 Brussels time. Thank you so far.
Good afternoon and welcome back after the lunch break. I hope that you have enough time to have your lunch. We are gonna back to the second item of the agenda, of the panel discussions, and now we are going to the second item of the agenda, and it will be covering the integration new solution in action plan for noise. So now we want to listen more about the practical aspect, how we can integrate this practical aspect into the plan for noise. For that, we have the pleasure to have with us today Professor Littricia, and I would like just to mention that Professor Littricia research is dedicated to developing models and measurements technique for assessing environmental pollution and mitigating noise exposure in urban areas, developed in international collaboration in different EU projects. He published more than 160 scientific papers, and he has a national habilitation as full professor in applied physics, and he's among the top 2% of scientists of Elsevier for 2022. He collaborated in order to prepare the World Health Organization and European Environmental Agency guidelines, as well as IEC and ISO standards. So, Professor Licitra, caro Gaetano, the floor is yours.
Okay. Thank you very much for the invitation and for the opportunity to share with you my experience and also the knowledge that come from many projects that were done in the past. So my task is speaking about some. Can you go on, please? The next one.
Now, Gaetano, before you jump into the presentation, please, you have half an hour to have the frame presented, and then we have half an hour for discussion, okay? So just a call to try to stick to the time that you have.
2 o'clock, it's simple. 2 o'clock Brussels time, everybody starts with chatting.
Okay, thank you. So the outline of my presentation is about the action plans in urban and suburban areas, because we need a different approach. We have, in many cases, a complex environment, so there are many and different contributions, so different sources. I will speak about how we integrate the different solutions, the possible role of the intelligent transport system to reduce the noise, and finally, innovative noise barrier. So all this because this will be the fil rouge of the presentation. Payments and low noise payments is one of the actors in this business. I mean, it will be not alone. The next, please. Noise, and particularly the vehicular noise, is one of the most important impactful source for health in Europe, and these were the results of the WHO studies. reflecting different kinds of problems, starting from the high annoyance, finally for the cognitive impairment in future. Please, the next. The next, please. Okay. As we listened before, the speed is a key to understand the phenomena about the interaction between tire and pavement. We know that after 30 kilometers per hour, because in the past, in the summer book, that was like a bubble for us, there was 50 kilometers per hour. But years by years, this speed was decreased. In fact, the size of the tire increased the noise coming from the rolling noise. So starting from 30 kilometers per hour, the problem is rolling noise. Under this level, the key factor is the engine, so the noise engine. In order to be clear, electric cars cannot solve all the problem of noise. Can help a lot for the air quality, but not for the noise, if the speed is a greater than 30. Please, the next. About the phenomena, we already listened something about, so I will run on this point. I remember, just to summarize, we have two kinds of phenomena. The first one is the rolling noise is due to the mechanical vibration that are induced by the contact between the tire and the pavement. And next one, please. The second one is the amplification mechanism that came from the horn effect, so the compression of air with the rolling, and some resonance that could be can come from this interaction. Please, the next. So, which pavement in which context? Action plan in urban and in suburban areas follow different approach, as we saw with Filippo before. Different speed, different composition of the traffic, different distance of the house to the source, possibility or not to act on the propagation. Practically, if we can or not put a barrier between the source and the receivers. Please, the next. In suburban areas, which are the pavements that we need? Speed is generally high, so rolling noise is predominant. Drainage asphalts are easily cleaned by heavy trucks at high speed. Low noise pavement can help to reduce the height of the barriers in an integrated approach. Please, the next. How relevant is the pavement maintenance? This is an important point because if you significantly reduce the emission for new vehicles with the directive, above all considering the tire directive, but also a lot of other directives regarding the noise produced by the vehicles, nothing done on road maintenance. So noise maps don't consider typically the health status of pavements, and this leads to a difference of several dB that the people experience in their life. Considering also that this could be different in different places, in different countries, depending on how much the government or the municipalities pay for maintenance. Please, the next. What we tried to do was to make like a noise map of the rolling noise or something like that, considering the status of the pavements. We put a sensor inside the tire, and we monitor the level during the movement of a laboratory that pass on different roads. You can see here that the sensor inside the tire is able to recognize a pothole. In terms of frequency, you see the effect, and you see also the view of the pothole on the road. In the map, you can see different color for different level of distress of the road. The green will be a good road, a good status of the road. The red one or the other color will show us the different levels of distress of the road. This area is close to Pisa. You can recognize the airport of Pisa and the Arno River. The next, please. The study that we did tried to put in relationship the tire cavity noise, so the noise that we measure inside the tire, and the road detector, that is one of the parameters that already Filippo shows before. We found a very good relationship. This means that the method could give us important information about this parameter that is related also with the noise emitted. The next one. And you can see again a road in a good condition. So you can see that the level that we record is quite flat. In terms of frequency, you can see this yellow line that is only the resonance frequency that is produced inside the tire in a normal condition. And in comparison, you can find previous road with some problems, evident problems, and you can see the difference in the spectra and the difference in the profile in the time that we record moving with the mobile lab. This means that the method is quite sensitive to the problem and can describe correctly the problems. Other methods are available in literature and on the market, but this system is very cheap, is a low-cost method, and could be also a good tool to better describe the noise in the city and in the area where we need to tackle the noise problem. Next, please. Here again, another map inside Florence, in the area where there is the stadium of Florence, where Fiorentina play football. And you can see here the green good condition road, but also some parts where there are some problems. And you can see here the photo. We are working on artificial intelligence system in order to recognize also the kind of the stress that the road presented. This could be also useful for the maintenance program, because the management of the maintenance should be really relevant in the city. Go on, please. We move to complex scenarios, because in our city or in extra-urban area, we have many situations in which we have not only one road and one source. Just to have an example, harbors are an example of many sources, because they are at the same time industrial, infrastructure, road, railway, ship movement, and other sources. So this means that we need a method to describe this source, also because we need to set who pay, because this is another point. When we have an action plan, we need to distribute the cost of the action plan. So we need to know how much is the contribute for each source that is involved in it. Go the next, please. We develop, in this case, a method because we know that the European Noise Directive asks us to produce noise maps for the day, for LDN and night, for each source independently, and a strategic map that put together in one map. But this way to show to the people the results maybe is complex, is not easy to produce, because we need at least 16 maps in complex areas. It's a long work. But in this way, we try to put all the data in one map. And you can see here, this is Cagliari, the port of Cagliari. You can see different colors for different prevalent source. And for each source, we use a different symbol. In the picture on my right, you see a zoom of this part, in which the color is the level that we find, and the shape of the symbol represents the different sources. In this way, in one map, you have all the information that you need. So you have the level, so the criticality is the point where the level is higher. but also the source that is prevalent, that will with the impact of this source in that point. I mean, in which that source is more important. This means that the receiver can understand which is the cause of his problem, and also the people, the authorities that should prepare the action plan knows who is the guilty source. You say, I mean, the people that have to pay to reduce the noise, and this will be really important when you have many sources that contribute to the same receiver at different levels. The next, please. And complex scenarios there are obviously in urban area. In this case, we are partnering in Life Silent. Life Silent is this morning Patrizia Bellucci introduced. Life Silent is a new project that just started some months ago. And in Life Silent, we are working on try to harmonize different noise mitigation solutions, because the problem of noise is needs an holistic approach. You cannot solve the problem with just one way. For many reasons, because the reality is more complex than what we can model in a laboratory, because you have a different situation with a different distribution of source and receiver. And this means that there is not, again, as Filippo said, one solution that is perfect for everything. The next, please. In this case, we selected 7 different scenarios with different situations in which highway and road are present in different conditions, different environmental conditions. And we select this in the box of all the scenarios that ANAS and RFI, that are the company that they have in charge the action plan in Italy for railway and road. Please, next one. You see just one of these. In this case, you have a big hotel. I don't know if you see my mouse in this moment, but you have an hotel with a lot of floors, but different height, deep house between road and the railway, house in front of the sea that are impacted by the railway and the road. So a complex situation that is typical in Italy, where we have a lot of mountains and road and railway run together parallel in many areas. So in this case, you cannot take the problem, just put a barrier. If you put a barrier, maybe you don't solve the problem, but create a new reflection for new receivers. So but this is the reality. So we have to take this situation. In this case, just to give an example, we built like the picture that you find above, where there is an house, a car, another house, another source, and so on. So in this case, maybe you can have a sensitive receiver. In Italy, in the action plan of Italy, the sensitive receiver as a priority in the action plan. So also this introduces a weight factor that take into account the relevance of the sensitive receiver. Could be an hospital, a school, or many other things. The next, please. So Life Silent propose a combination of solutions. In this case, low barrier close to the railway with a new design using metamaterials to increase absorption, or pavement using recycling materials, rubber from used tire. We did in the past other projects that were already presented, Evia, SNEAK, Nereide, in which we tried to introduce this pavement with good results, because practically rubber in the pavement introduce an improvement in terms of performances, but also durability. This was the experience of the previous project. Please, the next. There are other possibilities, not only payments, but something that is close to the payment. In this case, noise diffractor. Noise diffractor is based on a physical principle of diffraction when you have cavities. And in this case, you can obtain with a diffractor of 1 meter wide, 2.5 dBA of noise reduction. What is the problem? That this effect is only in a range between 800 to 1200. That is a range important for noise coming from the road, because it's the part of the road that is the part of the spectrum that is really dominant in general. We go the next. The step forward was introduce many diffractors with different sites for the cavities, and arrange, just to have an idea, this structure on the top of a barrier. The next, please. In this case, you can see here the results of a European project, Whisper, that in which there is this kind of barrier on, I mean, this kind of diffractor on a low barrier, and also the diffractor that was used along the road. Next, please. Which are the advantages and the limits of this method? Sure, the duration is more than 30 years, so it's good if we compare with the low noise pavement, because low noise pavement suffer of normal degradation of performance in the time. Reduce the visual impact, because we have not a barrier, so it reduces the visual impact, and it's possible to combine with barrier or low noise pavement, and in this case we can reduce the height of the barrier, because we have to take into account that in normal condition with the pavements we don't respect the limits, because in Italy we have the limits fixed by the law, and when there is the action plan, the goal of the action plan is to try to respect the limits. In this case, with only the payments, it's impossible. But if you add to the payments other solution, you can combine a new way to obtain the results. The limits. You need an accurate modeling for providing effective reduction performance in wide frequency band. It's not trivial work. You need the space, because larger is the diffractor, better is in terms of reduction of noise. You have the problem of maintenance, as you have for payments, because in any case you have to guarantee that the cavities remain void, otherwise the effect of diffraction is reduced. And this means there is a cost of maintenance. So maybe we need more time and more tests to verify how much are important the limits or how many are the advantages, but this is a permitting solution. Next, please. So the payment is, as I said before, is not a solution, a one solution for everything. Low noise payment could be really important, because can permit us to reduce the height of the barriers. The people don't want the barriers. This is what is our experience. They don't want the barriers because the barrier create problem for the climate. There is no circulation of air. The barrier is terrible for the view. Italy is a peninsula with a lot of coast, a beautiful place to see. If you put a barrier because the railway is closer to the coast, the people complain a lot and avoid, in any case, and fight. And the major do specific ordinance to block the implementing the barrier. So we need other solutions. So payment could help us because it can reduce the height of the barrier. Also, we can use a diffractor because a diffractor implement other solution without a visual impact. We have other solution in the city particularly, but in that case, we need to reduce the speed, or we have to work on traffic management. Please, the next. What we can do? We can introduce a zigzag road, roundabout, or in terms of traffic management, greenways, speed limit control, intelligent transport system, and zone 30. I will try to, in few words, to describe these things. Go on. So one solution in the city typically is put speed bumps and bollards, but they are not a very good solution because they introduce problems on the pavement. If you have one above all, you have more noise than before. You reduce the speed, but you create noise. So this is not good. Go the next one. You can introduce a narrowing of the roadway because this forces to reduce the noise, and this could be good. We have some reduction, some dB less. The next. In the case of Berlin, they try to reduce the lanes because if you reduce the lanes, the speed will be decreased. And in this case, they substitute the lane with a bike lane. And this was obviously a reduction of noise. Please, the next. Green wave and red wave push the people to maintain a stable speed, and this reduces air pollution and also noise, because when we accelerate or decelerate, we increase noise production. Go next. Roundabouts. Roundabouts is a good solution to have a fluid traffic, but after the roundabout and before the roundabout, you have an increasing of noise because the car accelerating or decelerating. So again, you move the impact to one place to another place. Go on. You can reduce the speed, in this case, or reduce the number of cars or vans for heavy truck. And these are other possibilities that reduce the noise impact in the city. Next one. Zone 30 was developed in the last years. Many cities are working on that. In this moment, in Bologna, 70% of the city is on 30 kilometers per hour. In many cases, 30 kilometers per hour is not difficult to reach because the traffic is so blocked that your speed is low. But in other cases, should be exceeded. So this could be a good way to reduce the noise. The next one. We have to remember that the road accident is very important in Europe, and the number of the accidents in the city are the 70% of the total, with the 44% of the deaths. So this point of the speed could be important not only for the noise, but also for safety. The next one. The probability of survival when you have 50 kilometers, you are at 50 kilometers per hour for a pedestrian is 10%. 30 kilometers per hour is 90%. This means that the European objective to reduce 50% the fatalities on the road could be helped by this. The next one. So the summary which says that if we reduce the noise and reduce the air quality using a low frequency, we also have a good results for safety. Go on. Traffic management. Traffic management is typically used in all the city to guarantee or to avoid congestion, but it could be also a solution or a tool to reduce the noise. The next one. We try to implement a new approach based on traffic management software, that we mean traffic model that can help us to know how many cars in which speed and where they go, so in a dynamic way, and use this approach to reduce the impact, not only to reduce the congestion, because our goal is sustainability. It's not only to reach the aim, I mean, where we want to go in the less time is possible. Our goal is to reduce the noise. Next one. In this case, what we do is we create a system to monitor the cars by camera and using artificial intelligence to recognize and categorize the vehicles, as this data as an input for a traffic model that produce a distribution of vehicles on the road, and using a noise model, we can have a noise map. Using the noise map, we can analyze if there are exceeding place. I mean, there are problems for noise. We can change the traffic distribution and make another noise modeling and so on. So we try to do a noise dynamic map using a dynamic model for the traffic. The next one. You see here the system with the cameras artificial intelligence categorization using Knossos categories. That is another step forward, because we know in Knossos we have 5 categories. We produce the noise exposure using software that is open source. So this is open to the people to use without any other cost. Next one. Is possible using this kind of approach, produce also DALI map, which are the DALI map. DALI is an indicator defined in the WHO publication, in which it's possible to calculate the impact in terms of health effects of the noise. And we were able to describe in the city where are the people that could suffer of these problems and will live years of life in good health. The next one. So I go to the conclusion practically on time. Incredible considering that they have 40 slides. So noise action plans on urban and suburban roads benefit by low noise pavements. This is sure, and we have the experience to say this. But road maintenance is a key. We can have a beautiful pavement, but if we have not the maintenance in the time, also because typically the pavement is cut by many guys that put wires and other tubes and anything, so they destroy what we with hard work did. So road maintenance is a key. Holistic approach, because there are we are not wizards. I mean, we have many possibilities, many tools. We have to combine them, considering the context and the aim of our works. We need guidelines, and so maybe European Commission can work on this with the experts that normally help them. Also with new projects that are finalized in this scenario. That is the reality. We don't need other, you say, prototype or pilot case. We need solution for the reality. So this is the key that we try to obtain with Silent. Thank you very much.
Thank you so much, Gaetano, for this clear presentation. I mean, it's clear how to have all this map where you identify the source of noises, and then, as normally, it's not easy to put forward only one solution, but it's just a combination of many parameters that you have to put in practice in order to mitigate the noise. So now we can maybe move to the questions, and I'm gonna start like Gaetano. We have the first one. This is the following one. Most important question in action planning process is cost. Can you highlight the main advantages of low noise pavement comparing to the other solution to reduce noise?
Well, it's difficult because the question obviously is very general. Typically, we can say that the cost, you need any time, in any condition, change your payment, because the degradation of the payment is a normal. And you need to have maintenance for safety reasons, as we know. So the cost is an added cost if you use you change your payment. I mean, we have to consider in the cost only the difference that we spend when we lay again a payment, only the difference between the new payments, the new payments with a special performances respect to a standard one. Otherwise, we don't consider the needs that in any case you have to spend that money. So this difference, I think there are some studies in literature show that the cost of low payment noise can be recovered in the time. Obviously, the durability of the performance of the payment is the key. The use of fibers, as Filippo said, the rubber in the payments, or other systems are going in this direction to increase the durability of the payment to compensate for the extra cost of the payments, of the new payments. So I guess the LCA that are already published is shown that in any case the cost benefit is positive. I mean, you can spend for something that is useful for your solution. I remember that in the publication of DG Environment, that if you spend €1 to solve the problems on noise, you save 29. So this means that spend money for fighting noise is good for the collectivity.
Thank you so much, Gaetano. So the next one we have is the following one. To use new solution, we need information about the effectiveness, implementation cost, maintaining cost, profit per number of people covered by the action. Are there any study good practices collecting knowledge in this area? And now I want to open also the floor to other participants. For example, Patricia or Giulia, you have been implementing projects where you have been facing this type of issue. Maybe you can also share with us the experience. So, yeah. So the question is, yeah, how if we need information on the effectiveness, implementation cost, maintaining cost. So do we have knowledge and information there that we can use?
For my point of view, and after I will wait for other comments. For my point of view, the interest of, in this case, rubber asphalts in Italy was increased in the time, because now we have maybe 700 kilometers. But I know that in other countries like Spain and Portugal is quite diffuse. There is also some law that push to use the rubber, because rubber, if we don't put in the payments, go in landfill. So it's a cost for the community. If you reuse the payment, improve the results. And we are sure about it, because there are thousands of papers more about this. Rubber is an example. Maybe there are other. The idea is to try to have something that go in the direction of the green economy, in order to reuse something that otherwise is not more used. I mean, it's going to landfill, or worse, it's banned in the case of tires. Our experience is based on the action plan that are in Italy the last 20 years, something like this, because the law for the action plan for the road was in 2004. The owner of the infrastructure prepared the noise action plan, taking into account the levels, the number of the people exposed, the cost, and so on. And in many cases, they try to introduce the low noise payment. Why is it not so diffused? Because the resistance is also cultural resistance. Because in many cases, the road remain the same that 100 years ago. The technology of the road didn't change. There is the cultural resistance also in the office, in the municipalities, because there is not the knowledge. So we need to do more about this point. We need more like the event like today, because we need to reach more people that decide for the future. The other problem is there are rules, law that is a European law for the contracts, for the tenders, and it's difficult that the people choose for the best solution. They look for the less cost, because less cost is more easy to close the tender. And this is a key point. We need to fix minimum environmental criteria, and we have to give benefit for the people that use green asphalts. Otherwise, cost more, they go to the tender, they prefer the low-cost solution, and we have not this possibility. I don't know if this point is clear.
Listen, Giulia, then we go to this most asked question.
Patricia or Giulia, do you want to do something to share with us or to complement Gaetano's?
I would like just to say that low noise pavement is not just a question of cost, but it's also a question of benefits, because low noise pavement allows to impact all receivers, not only a part of the receiver, just as just as barriers, noise barriers. So we have to take into account also the benefits of low noise pavement, not just cost.
Giulia, you want to react or provide your input? If not, we move to the next question. So the next question is the following. Bad road conditions are not counted for a strategic noise maps. How much can noise be decreased by fixing road? How to include conditions in maps? So that was covered in your presentation, Gaetano. So I think that
this is an important point, because have you seen in the previous presentation that normally every year the payments lose in average 0.5 half dB. So it's normal that the quality of the road decrease in the time. But if the maintenance is completely absent, the effect would be worse than 0.5 dB per year. And a road, have you seen what is relaying after 12 years? So typically, the difference is between two roads in different conditions with different traffic on the road can be 5 dB. So we have maps that don't reflect this situation. They just put a number in all the roads, considering all the roads equal. So this is typical in Knossos. It's possible to fix a default value. So if you put 0, it's a 0. You can put maybe -1. Okay, if you know, you can put different value for different quality of the payments, but typically nobody does. Nobody do. So nobody does. So this means that the map are not really credible for this point. So we need to develop systems. I show only one system. There are others, maybe more sophisticated, but also more costly, that permit to know and to build this kind of maps. So my advice is try to promote this solution also with a new study, with new methods, with new projects. But this could be something that we need to cover in the future.
I can complement with an anecdote. I have to tell you that in the discussion we're having daily with the automotive industry, this is a point that is frequently raised. They say, you don't have to ask us to make quieter tires or quieter vehicles. You need to ask the road authorities to fix the roads. That is the problem. So honestly, we are facing at policy level, as European Commission, as European ministries, this debate when trying to reduce the noise at source from the vehicles themselves. So it seems to be not only the most voted question in Slido, but it is indeed also something that we face with the other counterparts, so with the manufacturers daily.
If I remember, excuse me, Marco, if I remember, the automobile companies and associations say that to reduce from 1 dB the engine noise, they spend 6 billion euro. This means that we more easily and with less cost, we can improve the quality of the roads, reduce reduce the problems for safety, and reduce the noise. So it's clear that we have to work for that. We need more indication from DG Environment about this point. Or I don't know if the role, I don't want to go in a question of who is the principal, but obviously it's a collaboration with someone depending on the role of the DG of you that have to promote some principle, and help, and the science can help also with new solution, and the Life Horizon and other program can help to develop these things. But without, we are in a mess in which automobile cannot spend because they say it's useless. the tires. We tried with the directive, and we know the resistance of them, and also the difficulties to find the methods and so on. I don't want to go into the details. On the road, nobody speak and remain all the same. I think they have some reason to protest, to complain.
Gaetano, that is clear that is like a collective type of effort, so everyone can contribute. So, but now I see that Bert and Ronald, they have their hand on, so maybe you want to comment or to make your contribution.
Thank you. Two things I want to say. The first thing is about Knossos and maintenance. So to be clear that the current road correction values that are in the Knossos database, which are the Dutch values, so they come from us, right? But also values that we've been deriving for Ireland and the UK, for instance, they are lifetime average values. So if you have a new pavement, you will get higher reductions than what's in the Knossos. And if pavements are old, they will get lower reductions. So they're an average over the lifetime. They're not new. We have considered for Ireland, for instance, to have separate corrections for new and old surfaces. But well, as I think Gaetano said, nobody will have information about surfaces, whether they are new or old, right? So I think it's a practical solution. I think it's more practical to have lifetime average values, but you should not base your correction factors on new pavements only. So that's I think an important thing, which is already in Knossos. And if you read the Knossos text carefully, you will read the same thing. And the other thing I wanted to mention was with a question with regard to cost. I noticed that people are looking for cost figures. I know that at least our National Road Authority can give you these kind of figures on maintenance costs and investment costs, etc. They have detailed information. I think that there was a CEDAR report also a couple of years ago that gave cost figures for low noise pavements. I think also in comparison to noise barriers and other solutions, but I'm not entirely sure. And we used to have on our website also a cost tool for urban situations. One thing is that, you know, the raw materials have become more expensive over the last couple of years. So these kind of tools need to be updated with new values, right? You cannot just use the same values for 10 years. So I guess we would need some efforts to update these values. But at least there is experience with getting the kind of cost values in our National Road Authority, also in urban areas. So if people are looking for information, then it should be available in Dutch, but well, we can translate stuff, right? And maybe this should happen on a European, maybe CEDAR level, to get some exchange some information.
Fabienne, do you want to also to contribute or to add something else?
Yes, it was about how to include the road condition in noise maps. It was just to mention that in the draft standard that we're working on at CEN and that Manfred Heider also mentioned, we suggest one way of introducing the real road condition correction coefficient by a kind of scanning of the network using a CPX tool. And so you make a kind of snapshot sorry, of the network in real time and can introduce this value in your map.
So the solution is the other ones are, you know, on the topic of today. But
Manfred, you want to complement? You are muted.
To complement what has been said, it's definitely necessary to take the time component into account when giving emission parameters, and I think that's also in principle foreseen, that you could also have even varying parameters over time. Currently, as far as I know, most implementations choose, as Bert has said, lifetime averages or averages that are a little bit on the safe side. Because that's easier to come by, but it's definitely necessary to have something at least in a representative maintenance status, not in a completely new condition that's maybe gone in a month or so. And I think there is a good reason that we, as Fabienne said, introduced also this proposition to really start the monitoring, because of course you can have much better information on this if you have the data. So if you really start monitoring the network, or at least those pavements which are important for your noise mapping, then you also have the data to back up any changes in parameters. And concerning the cost effectiveness, so even if we leave out all the socio-economic effects, speaking from Austria, also the cost alone of noise barriers is already a major factor in the trade-off with low noise pavements. So building, you know, that in a noise barrier, usually the lowest parts are the most effective ones, and if you have to go higher and higher to reach the limit values, usually the upper parts are the ones that have the least contribution in terms of dB. And if you can save basically at least the top part with having a low noise pavement, that's actually a huge decrease in cost. If you leave the height the same, it's an increase in benefit for the residents. But and as said, it works independently of where the receivers are, which is a general benefit compared to any barrier.
Thank you, Manfred. Very clear. So we can maybe now move slowly to the next question and relate to is Umesh from UK. And when reduces speed, probably will reduce noise, but probably will increase other emissions with longer duration. Could optimization give better solution? So does anyone want to react or to try to reply to the question? So basically it's like a balance between we reduce the speed and then we gain something, we reduce the noise, but we might increase like other emission that can have another impact. Is this the case, yes or no? And how to take that into account?
I would guess that reducing speed also reduces emissions, right? We need to accelerate less. You use less fuel than driving, getting up to 30 than getting up to 50 kilometers per hour. So I think it's what Amsterdam recently reduced speed to 30 kilometers per hour on many roads in the center. I think one of the goals was to reduce emissions, actually, not to increase emissions. So even if I understand the point that vehicles will be around for longer in time, but they will accelerate less, I would say it saves fuel and also saves emissions.
Maybe I can say something about, because I think that the question is based on information that was in the web about the best combustion that you have when the speed is higher. This is the point. So the question is not related only with the speed, but the speed is a part of the question, or part of the problem. And I agree with Bert when he say we reduce the speed, but also we reduce the acceleration and deceleration. That are the most important point for emission, for air quality, for air emission, and for noise. So the best idea is manage the traffic in order to reduce the acceleration and deceleration. And this means normally reduce the speed, and also we have other long-term effect in terms of safety. So in the future, when we will have only electric car, because it's a question of 10 years maybe, or 15 years, in this case, we in the city, if you consider normal roads, we have no problem, because if we reduce the speed and use only electric car, the noise will be less and less. But remain important road inside the city, in which the speed is not 30, because are the road that connect different parts of the city or the suburban area, in which the problem of noise will remain, and will be maybe greater, because the sides of the tires are wide and wide, and there is results of the last studies that show that the size of the car is increasing 2 centimeters for each year. So the problem will be have a car that cannot come in the city because the roads are for medieval age, where the sites were less and less. So this is the problem. So we have to change the approach with the car, because the car become greater and greater, heavier and heavier. And this is, on the contrary, will increase the noise for the rolling. And in any case, not only for the combustion, but for the normal fuel, but also for the electric car. Larger and heavier means wider tires, more noise.
Manuel, perhaps can I ask a question? Of course. I want to take this opportunity to be myself. I see the complexity of the decision where to have low noise road surfaces, and also where eventually to introduce or to combine other solutions. Now, I'm looking at Gaetano, but honestly, I'm looking to all our panelists. Can we think of a software or artificial intelligence that will be able to solve this problem, you know, to give us the right answer? Because I see different inputs there. You have strong arguments to say there are situations where you would go for other things that low noise road surfaces, and there are situations where you would go for low noise road surfaces, but it's a question of explaining that the cost and the benefits in the long term, they are positive. So instead of being where we are now, that I feel we are today in a situation where the single expert or the single city decides arbitrarily if to go one way or the other, depending on, I don't know, I think whether he likes or not one or the other solution. Can we think of something which is adapted to the technologies of 2024? I mean, artificial intelligence. Gaetano.
Yes, sure. Artificial intelligence is everywhere now. I mean, we are using artificial intelligence for many applications, and I think also we can use it for noise action plan. We saw the work and the slides of Filippo with so many parameters, and obviously there the expertise of the researcher is fundamental to find the best solution. But in the future, this knowledge will be transferred to a computer. The condition to do that is have standardized data, because if you cannot compare results coming from a researcher that use different indicators or different parameters or different conditions to do the measurements. So we have, first of all, so the role of standardization is crucial in this, have data that are comparable. The work that we are doing in Italy is based on practically a group of people that is doing different tests in Florence, above all, because Florence was a lab for us for 4 different live projects. So it's an incredible condition for us. But in the same time, we apply artificial intelligence to recognize the signal inside the tire, or use the artificial intelligence to categorize the vehicles. We can use artificial intelligence to choose between different scenarios for intelligent transport system. So is a key, but it's question of time and question of money, because finally, if we want that we can, I mean, diffuse the application of this, that there is on the base the cost of the study to do that. So this will be the key for it.
Yeah, thank you, Gaetano. So now I think that we are reaching the time allocated for this item in the agenda. So now we move to the last question that I think is very relevant. And the question is the following. There are many different pavement mixtures, technology, etc. Are there any good practice guidance for policy makers how to choose the state-of-the-art solutions? So do we have any ready available guidelines that can be used by policymakers?
I think it's a bit the question that I raised before, in a sense, before I went one step too far. I said artificial intelligence to choose for us the best combination of solution depending on the location. And in this case, the question is, waiting for artificial intelligence or software to decide the composition of the road surface or the location where to have a low noise road surface or other solution. Are there, good practice guides for the policymakers? So I think probably the colleagues are thinking of person in the local office, in the municipality that needs to decide. Does it go for 30 kilometers an hour? Does it go for the roundabout? Restriction of the road, the bump?
But I remember in the past that the European Commission funded some project about best practice for action plan, in which also payments were part of them. I remember F-noise, just to say a name, or the other was something like us, if I remember correctly. So they were, but after this, no more. I mean, there was like a block, we did this work maybe 10 years ago, but after there was no other occasion to put together. There is important work by CEDR that sometimes launch some, maybe Manfred can say more than this, or Alicia. CEDR promote some activity for that, but are strongly oriented from extra-urban area, not urban area. So we need something in the city, because in the city there are the biggest part of the people live in the city, and will be more and more in the future. So we need to act for that.
Manfred, you want to complement? Or
yes. So if you go for a quick answer, there is a good guide. If you are basically a road manager, there's a guide by CEDR, which could serve as a good starting point for that. If you go to the CEDR website, you can look it up. Also, CEDR has done some calls where there were projects that received that produced a lot of interesting material that you can use as a starting point for this. So that's would probably be my first start. But I've just looked it up. The report itself is from 2017. So you're right, Gaetano, this is all a little bit aged already. So and a little bit of update on this would of course be beneficial.
Excellent. I think we have a next question, again, going in the direction of guidance, of practical experience on requirements regarding noise for porous of other low noise pavements, and how they are controlled. So is when you tender, are there tender specification available? I think this is a good introduction to our third panel discussion on standardization challenges. And I think the discussion today is heading towards standardization. I felt that more and more the question is not having available knowledge on where correctly you have to have this kind of solution, or how effective they are, on what are the costs and the benefits, but on having too many standards, too many tender specification, too many approaches for the same problem, if not the same solution. And therefore, with this in mind, I would like to give the floor to Manfred again, that he will have a short list of questions, because we will talk for the next 45 minutes about standardization challenges. Manfred, the floor is yours.
Thank you. So I will not go through a very long presentation, because I've already talked a lot in the morning. I've just tried to list here a few of the challenges and discussion points that come up when performing standardization in this area. And I've grouped this more or less on 3 slides. And I hope this will serve as discussion starters and points of reference of thinking, and also shows a little bit where we which question we still have to answer. So in terms of low noise pavements, it's very important that we have a clear characterization of those pavements, because if you're in the situation of somebody trying to use this as a tool for noise reduction in a road network, it is necessary that you have certainty good level of certainty that the pavement will perform as a noise reducing measure. This means you need to have parameters. You need to have a method of checking if it's really a low noise pavement, if it's also a low noise pavement along the whole section that you're building, because as we said, there can be localized changes. That sometimes there's some variation, maybe also allowed by the type of pavement specification that you're using. So this means that you not only have to say, I want to build a low noise pavement of this and this, or this type. You should also be sure that really it really does fulfill what you are expecting. Currently, there are a large variety of pavement types across Europe. So if you start from the asphalt mix, if you just restrict yourself to asphalt, there is a high level of standardization there. But if you go to national varieties that are used, you see that, okay, there's some kind of asphalt concrete in every country. There's usually some kind of stone mastic asphalt, SMA, in every country. But then there are specialities. For example, for concrete, you have countries which use exposed aggregate concrete, or who use even longitudinally grinded concrete pavements. Some like to use thin surfacings, some to go to very slow aggregate sizes, even to 4 millimeter. This varies a lot among the countries. And then, of course, you have also commercial pavement types with a lot of different designations where you cannot directly see what type of pavement this is, because it has some commercial name. So this list can get very long. This is as I said, in some area in the mixes that's well standardized, but in terms of what gets put on the road and how it turns out on the road, that we have a large group. And in the end, you need to know, even if you give this a new name, you need to know what are the parameters that I'm using for this, more or less independently of how it was produced. This is why a standardized derivation of emission parameters for noise mapping from measurements is very important. Even if you have a pre-existing list of, don't know, the 5 to 10 major pavements in your country, if somebody comes along with a new idea, it should be possible to incorporate this to also, at least after some experience, to derive emission parameters and to integrate this into the system that's currently being used, especially on the European level, which is used for noise mapping. This means also that, as I said, there are many names. Also a standard designation, or at least a standard set of parameters that you should give in connection with emission parameters would be very important. Just the name is very often not enough. You usually need things like a maximum aggregate size, void content, other parameters. Then we have different countries in Europe. Some of them use reference pavements, some of them don't use them. Currently in the European system, we have basically that's laid down for the noise mapping. You have a reference pavement, and all other pavements introduce corrections. That's the system that works quite well, as long as you also know very well what your reference is. There is, of course, the other approach that you say, okay, if I do a measurement, I have absolute values. I actually don't care where the reference lies, even especially if it's sometimes also a worse kind of virtual reference is used, like a mix of SMA and asphalt concrete. So it may be beneficial to just stick to some absolute values. And of course, this includes how do limits that you introduce for pavement also link to noise limits for vehicles and tires. Because if you have a vehicle that's dominated by tire road noise, the limits that the tires and the pavement are under will also be very important. And in the end, this all goes into the noise mapping action planning, because if you want to really show a benefit that in the end reaches the receiver of the noise in a residential building, then basically the effect of a low noise pavement has to be felt throughout the whole chain, from the emission through the whole propagation up to anything in the way of the noise. So this has to go through. So if you only have very rough categories at the beginning, you will not, if you just have something like concrete, porous asphalt and other asphalt, then you will not really have the possibility to show that your low noise pavement really has an effect. So this is very important. The action, of course, of deriving these emission parameters from data, this is of course something that's can be very intensive, resource intensive, and also cost intensive. But on the other hand, it gives you the opportunity to really say something about your pavement that really fits what the actual situation is. And in addition to this, of course, you also have the time factor. So these are the challenges when we look at the characterization of pavements, knowing which pavements there are and which parameters to attribute to them. Then there are some next slide, please. Then there are some technical points that relate to the types of measurements that we use. So the most flexible type of measurement that we currently have are the CPX measurements. Because with a trailer you can more or less go everywhere where there is a street and you can travel normally. It has a somewhat limited frequency range. So if you want to go from CPX measurement results to noise mapping, you have to make some assumptions, at least for the very high and the very low frequencies. This is something that we still have to work on. Then reference tires used in the CPX method are a topic. There is currently in the CPX method the tire for passenger cars that is used is the ASTM standard reference tire test tire, which is more or less standardized by ASTM. So basically in the US, and this is used for a lot of other purposes, but it has the advantage that it's a tire that it's available over a long time with the same rubber, with the same configuration, which is actually unusual for a tire, because as I said, usually the tire market changes much more quickly. The advantage here is that you have really a very good reference that you can use. This is something that's currently not the case with the truck tire. So of course there has been it's not a real truck tire, it's a tire that has acoustic properties that resemble truck tires, but it's a tire that underlies these market forces and is not available long term, because there's no institution like ASTM guaranteeing the long-term availability. And this is a situation where, currently we are working on methods to transition from one tire to another. But ideally, of course, we would have the same situation like for the ASTM SRTT, where there is really some institution that provides this over long term on a consistent basis. In the end, then also relevant for SBB pass-by method. So basically, you in an SBB you measure vehicle pass-bys of at least 140 vehicles, 100 of them are passenger cars. So this means you judge the noise emission by the noise emission of a relatively sizable population of vehicles. But if you do long-term comparisons, of course, it's not guaranteed that the tire and vehicle population will, or at least the average of the vehicle and tire population will stay the same. This is will especially, of course, be true if you go to a higher and higher a percentage of electric vehicles, which will not be a big deal if you are at high speeds, but at low speeds this will definitely change especially the vehicle population. And this, of course, leads to the point where how do we characterize electric vehicle noise correctly? So there has been research done on that. It's not something where we have to start from scratch, and the overall effect is known. So more or less we get rid of this. But I think we also have to take this aspect into account, that electric vehicles will have to be required to emit noise at very low speeds. So these are some of the more technical changes related to the currently standardized measurement methods. Next slide, please. And then, of course, as has already been mentioned, also low noise pavements do not remain unchanged after installation. So you can install the perfect low noise pavement, very good data from the outset, but of course you have to look at what is the long-term development. And different types of pavements will have a long-term development. Usually you have some kind of increase. You can also have some kind of cleaning effects, especially with porous pavements. And then you also have to say what is the expected lifetime of low noise pavements, what is the lifetime of low noise pavements that I'm also prepared to accept in my maintenance system. If you have the expectation that your pavements in general should last 30 years, then it will be quite difficult to use something like a 2-layer porous asphalt. So this is an important point, and this is also why it's definitely necessary to know more about the long-term development of all these types of pavements. What we have also seen in research is it's usually a little bit difficult if you try to compare pavements that are nominally of the same type of different ages, by going more or less through the network and seeing, okay, this is 5 years old, this is 10 years old. Usually you also incur the variation that's inherent in the pavement type. If your pavement type is not very, very closely defined and very exactly defined, you do not only see the variation due to age, you also see the variation, or include basically the variation within the pavement type to this. And maybe also pavement type or age is not alone the determining factor. It can also be argued that the number of vehicles traveling over this pavement, which in turn includes changes to texture that are basically caused by this, is more important than just the age. Then we have, as I already mentioned, we have seen that texture has an influence. We've seen that sound absorption has an influence. The question is also if there are some non-acoustic parameters which allow the prediction of acoustic pavement performance that could be used to get a better grasp on creating low noise pavement. So if you have a certain variety, for example, in your mix and also the laying procedure, but if you check, for example, the resulting texture, you have a much better idea if this is going to be a low noise pavement than just from the mix alone. So to some extent, non-acoustic parameters can be allowed to can be used to at least look at the possible range that is achievable with some types of pavement. Then, of course, maintenance and repair. So you can really change the surface layer of your pavement if you do repair. If sometimes you see yes, okay, we have concrete, we repair it with asphalt, and the other way around. Then you introduce discontinuities, you introduce a completely different type of pavement, and you introduce sometimes also a little bit of a patchwork. This is more prevalent probably on urban roads, but can also happen on higher speed roads. And then to some extent the status of the pavement is becoming more undefined, because it's no longer the same pavement along the whole stretch. It has more discontinuities, and this is also something. So you can either say a low noise pavement needs to be repaired in a way to maintain its low noise properties, or you have to, of course, track what you do and with what type of pavement you repair and replace a low noise pavement, and then you are aware of what you're doing. And finally, of course, low noise pavements in urban environments are usually a little bit different. You cannot rely on things like self-cleaning with high speed. This is a more complex. You also have more torque forces, things like roundabouts, like intersections, where you maybe cannot get the full benefit of things like two-layer porters. But this of course probably different in the different countries. But this is definitely something that we need to have a look at also to some extent from standardization. So I have raised a few points. I hope there are some interesting ideas and discussion starters there. Not all the answers are given. So in some of these areas we are relatively far advanced. In some of these areas there are still some questions open. And I hope I've enticed you a little bit to discuss some of the topics. Thank you.
Thank you, Manfred. This was pretty useful for us. You made a list of 20 different, something like around 20 different challenges. Perhaps just to start the discussion, can I ask you, would you select 3 priorities amongst the 20 that you listed there, and then we make a little tour de table on understanding, you know, amongst the different challenges. I understand there are many that you listed and many that were mentioned today. What would be the 3 top ones that needs to be addressed as soon as possible?
So if I have to go for only 3, that's basically the procedure to derive emission parameters for noise mapping from measurements, any kind of measurements, but to really have the possibility to attach to any kind of pavement noise emission parameters. So that would be the first. Next term, a good grasp and a good knowledge of the acoustic long-term development of pavements. And probably the third also, to really see, okay, this is a little bit connected with the first, to know which pavement you're looking at. The designation of pavements is quite interesting. I think the technical points is something that we can work on, and where we also are relatively far. Also, maintenance and repair, this works, but I think these are maybe the main points.
Yeah, thank you. And we have received a set of questions, so these are not forgotten. We will go for the question. I'm trying to organize a bit the discussion. So provided that in the next half an hour we will address the unaddressed question, but we will also head towards the conclusion of our workshop today. It will be over in say it like 40 minutes. So I would like to ask this question also to the other speakers and moderators, talking about the needs for standardization challenges. Do you agree with Manfred, or do you see other areas where there's a need, urgent need? No, Manfred, you are excellent. That's why we have you here, because you identified the 3 main ones. I noted them down: emission parameter for mapping, long-term development of pavement, and designation of pavement. Am I right?
Yes.
Okay, so that's well noted.
Maybe give us a minute to think about it, Marco.
Okay, I'll give you a minute thinking, but you need to be quick, Bert. That is, you know, in Brussels we are quick. You need question answer. Off you go.
No, I agree with Manfred, at least the first 2. So a good designation method for noise correction factors and noise calculations, I think, is very important. Should be priority 1. And indeed, how to cope with. Let's agree on how to cope with acoustic performance over time. I think I agree with the first 2. I think something on cost should also be considered a standardized way to talk about costs for low noise pavements. I think there have been many questions today also in the chat about what do these things cost. So I think and I think we all agree that low noise pavements will cost more than regular pavements, a bit more at least. Well, any noise measure costs money, right? So I think it's still cheaper than noise barriers, as I think Gaetano said. So I think, but at least we need to have comparable values or good values for cost, so people policymakers and decision makers can really go for low noise pavements with good cost figures. I think that's important. I would like to add costs to your list, Marco.
Yeah. Well noted. So let me see. We have some 5 main questions in front of us. Let me see which one can be the next one, trying to build upon the discussion we are having now. I think, yeah, talking about costs, I see 2 questions that have relevance for costs. And then one, is it possible to repair the low noise pavement and maintain its acoustic properties? Well, I would say it's related to cost, because it means you have these investments, but and we know that they will deteriorate. We said it's a question of maintenance. But before you go for repaving them after, I think, Bert, you mentioned 12 years in the Netherlands. So is there a possibility to maintain these surfaces so that overall the life cycle costs are kept to a minimum and the effectiveness of the measure to a maximum?
I think for motorways, I think our National Road Authority has been experimenting many years with prolonging the lifetime of low noise pavements. There are different methods to do so. You have rejuvenators, or you have different kinds of options, or replacing only the very top layer, not the entire. That's the different options that you can do. We did some research. Again, I think our National Road Authority has valuable information here that could be helpful. I don't know, Ronald, if you want to comment. I think for all these things, it is wise to do it not at the very end of the lifetime. If you have potholes, then well, you're too late, right? So you should do it before. If you're going to revive the bitumen and the asphalt, you do it before you start losing stones. Otherwise, you're too late, and then you're just conserving a bad asphalt instead of preventing that it becomes very bad. So that's some.
Thanks.
But I think we have
Ronald, did you want to compliment? This is one. Yeah. And then I see Filippo, you also wanted to intervene, wasn't it? Okay, so Ronald.
It's very important when you do maintenance. It's not you do it not at the end of lifetime and conserving an asphalt in a bad condition, because the inhabitants have 4 years a bad asphalt in front of the houses. So the best is to plan it, to plan when to do the maintenance. And for highways, there's a lot of experience about that. They can plan better. And that's in urban situations. I think it's more difficult to plan. You have different kind of roads, different road traffic load. So I think that is more difficult. And yeah, that's what I can say about it. Yeah.
Yeah, thank you. Filippo. We're talking about maintaining the roads. No, that was the topic now, and yes, repairing them, and so as to increase decrease their life cycle cost and increase their durability and their effectiveness.
So, as you know, there are 2 half spaces: maintenance versus rehabilitation. And when we talk about maintenance, there are other subclasses. Now, without going too much in depth, the decay of noise may be due to a decay, roughly speaking, in terms of surface texture. In this case, nothing can be done. Except that grinding or doing something like that. So in other cases, such as, for example, the clogging of porous asphalt, so yes, in that cases, a minor maintenance process is possible. So the answer, my opinion, is that it depends. In some cases, a non-destructive treatment is possible. In other cases, the maintenance means just to lay down something else on top. So it depends. I repeat, when we are dealing with an important modification of surface texture, so the only possibility is to lay down something else. If we are talking about a clogging process, in that case, it's probably a non-destructive maintenance process can be carried out. So the problem is at that point, given that, what is the best corrective or maintenance process? I mean, if you detected that the noise underwent an increase of 3 decibels, is this phenomenon associated also to a decrease of the friction? In that case, you will have a certain answer. So the problem is not related just to the performance in terms of acoustic performance. You need to analyze a couple or something like that of performance before deciding the best way to maintain or to carry out a maintenance process. This is my opinion.
Yeah, thank you very much. So I'll try to look through the question. There is a statement, as I think it is on this topic. Luc Goubert, he suggested maybe we should consider testing the next generation concrete surface in an urban area, as it may offer a very durable low noise solution. Is it a possibility? Next generation concrete surface. By the way, I'm not sure I know what it is. Next generation concrete surface.
Yes, I know what it is because Austria is one of the countries basically working on this, and we have a tradition in concrete surfaces, especially with exposed aggregate concrete. And new generation concrete surfaces, something that has been used in the US and is now being also tested in Europe, basically where you have longitudinal grooves in the grinded or into the concrete surface, which gives you basically this more or less ideal surface with very narrowly spaced plateau with grooves inside that allow the air to escape. So you have both a reduction of noise, of vibration and of air pumping. So this is why these pavements can really reduce the noise also for concrete pavements a lot. But this also requires, of course, that this kind of texture has to be stable over a long time, and that's the challenge here. So
yeah, I think, and I see there's another question statement. Correct me if I'm wrong, but I think it's it's on the same topic. The city of Rotterdam prefers clinkers instead of asphalt, says Jan Potter. We test silent clinkers. Are there others that use this type of pavement in residential areas? So if I understand, the clinkers are the same as the next generation concrete surface, and if so, then I understand that yes, there are not only Rotterdam, but even other situations where you're using this standardized eventually.
No, clinkers are paving blocks. Paving blocks.
Paving blocks.
Yeah, I can throw a picture in the chat maybe. But, yeah.
Okay.
No.
So there are also approaches for low noise paving blocks. If you make them very even and maybe even absorbing, you can also. This is for example for inner city areas. It's quite popular to have this kind. But these longitudinally grooved concrete is currently mainly used in high speed applications, so motorway. So using this in an urban area could be quite interesting. Because the main threat to this kind of surface is that these grooves and especially the ridges basically are rounded and even destroyed by a lot of torque, which you probably have more with a lot of turning and which occurs more in the city. But it could be interesting to really apply this in an urban area.
And perhaps talking about standardization requirement or the opposite of standardization requirement, there is a question a colleague asks if there are how many mixtures are protected by patents and cannot be used by other manufacturers. So when we talk about standardization and we say standardization challenges, but maybe there's something you cannot standardize because it is patented. Is it the case?
Yes, there are commercial pavements, usually also with commercial names that are used. It depends from country to country. Especially in Austria, we actually stick very closely to the standardized asphalt mixes that are in the European standardization. But I know, for example, I know in the Netherlands there you have a very long list of correction factors. Also, I think for commercial type, I would say pavements. In the end, if you can really pinpoint that it is the same pavement, and you can attribute a certain set of emission parameters to it, I think that's enough. If that works, and you should know the uncertainties, but if you really can identify these two things with another, why not?
Okay, I think what's the time? We have 10 minutes. I believe we in the context of standardization, which is a bit the scope of our discussion, I would like to shape the last 10 minutes of our discussion, entering a very specific question because I've seen two colleagues, they've asked something very similar, and then I would like to open up for the last, say, 5-10 minutes to all the speakers, so that in general we conclude a bit on confirming the 4 standardization needs and perhaps being more concrete in which actions we from the European Commission, if not from CINEA, from the agency, can engage. Okay, so I go for these specific questions. Quick answer, please. They are very specific. When considering reference tires, should we include also studded tires as they are commonly used, at least in the Nordic countries? And then they say, is it also worth considering replacing the SRT-TP1GPX reference tire? It is much noisier than an average tire actually available in the European market. These two.
Actually, I think that I can answer both questions. Ideally, you would have a reference tire that represents all tires well enough. Studded tires are a bit of a different story than, again, because of the studs. The point is, if you have a reference tire, you have to have it available long term. This means decades, and this is currently the challenge. And basically, currently we are lucky to have the SRTT, even if it's not perfect, but it is available long term in the same quality, and that's why it's currently chosen. And if there's not some institution willing to provide this on the same level, I think it's hard to move to anything else at the moment.
I think we are heading towards our last 10 minutes of this excellent webinar. The colleagues, they are reminding us that there was a question that was not answered. And perhaps we start from there. I asked all the speakers to switch on their camera and be ready to we have a last-minute intervention. So the last question was, are there any practical experience with tender requirements regarding other low noise pavements, and how are they controlled and enforced? So we are back again to the discussion on standardization, but in the perspective of tender requirements. But perhaps, I don't know, Patrizia, maybe you have an experience out of your hundreds of kilometers, tender requirements.
Unfortunately, I can't say yes, but because those test sites was not implemented by us, but we are going to prepare the required specification, not only for the light selling project, but also because we are going to start implementing low noise pavement. So this is an activity that we are going to start in a short time.
Fabienne and Bert. Fabienne.
Yes, to my knowledge, in France there are many experience with tender requirements, but there is not a unique form of tender requirements, and you have as many tender requirements as cases. So sometimes they are specified in terms of maximum CPX noise level. Sometimes they are specified in terms of noise reductions with regard to previous pavement. Which has nothing to do. Sometimes they are specified in terms of class of pavement, and sometimes even I've seen a tender with LAQ at facade noise reduction. So it's very diverse.
So, I mean, this is just also came to my mind, Fabienne, as well, like, is the power that have the public authority when tendering this type of thing, because you just basically, establish the criteria, what you want. So there is type of a power in the public authorities, right? I mean, as the guiding or the driving force, no? Because you can push for certain specification or requirement or type of asphalt, right?
Yeah, I'm not a public authority. I'm working in a university, but I know that the National Road Authority tried to force the tender, the road managers to have tender in a specific way, but they were not followed, I must say. So it's very difficult to enforce.
Yeah, it's difficult to enforce, but we have a good example by the project implemented in the city of Paris, where the public authority now is, as the replication of the outcome of the project, where they have been testing different asphalt formulation. They're gonna use as a public tendering in the public tender procedure. So that is, in my opinion, very good example where they have been working also with the construction company, so the company producing the asphalt, because this is very important. It was Bert was indicated today to work with. So this is, I think that it's very positive in the frame, for example, of a light project where you have all the relevant actors or stakeholders implementing the project. So you have the public authority, they are responsible, or they have the power for that issue. Then you have the scientist community, you have university or research institute, and then you have the company that is producing the asphalt. So, and then you try to test or the solution. So that is very right. So I think that we should use more like the program that we have available for putting in practice this type of project, maybe. But now I think that also maybe Ronald and Bert, you want to make some comments?
Tell about the experiences with the tender requirements. We have a lot of experience with that, and especially in the urban situations. Because of in the urban situations, we have a lot of low noise products, and all different asphalt products from different manufacturers. So you have different acoustical properties, and it's very important to describe or to prescribe before the asphalt is laid what you want, how many noise reduction and so on. And then we in the requirements always there is required that the project that will be laid has the noise emission parameters. So it's the responsibility of the road builder to have that parameters. And after the asphalt is laid, we mostly SVB or CPX measurements are performed, and the CPX is important because you can measure the whole length of the road track, and the SVB measurement is sometimes added to the CPX measurement because you want to know very exactly what the noise reduction is, and if you want noise reduction for for different speeds, or for example for heavy vehicles, then the SVB measurement is more is better than the CPX. So yes. Yeah, and for the maybe another point for the CPX measurements is always if you the tender requirements and you do measurements and you control the if the noise reduction suits the requirements, you had to take into account the accuracy of the method, and it is important to that you describe how to deal with the accuracy. If you find a difference of 1.5 decibels, what do you do? Actually, to replace the asphalt, or do you say, okay, we have a difference because it's due to the measurement method? That kinds of things is it's important to think about it before you got a discussion with if the asphalt is okay or not.
Thank you. Anyone else want to intervene, complement?
Then we go back and try to lead towards our conclusions. Again, you are all here. Well, first of all the participants, but also you panelists, and we drafted a list of 5 different areas where we need standardization. And I would like to say that for me, for the European Commission side, that would be the job to be done from our side. So to look into pushing for standardization is what we can do. Perhaps the panelists, you have it in front of you on the chat, and maybe you can intervene one after the other and mention which ones you believe are the most urgent ones.
Maybe, yeah, Fabienne, you already replied the chat, so maybe you can share with everyone.
Yes.
Yeah, maybe we can share. Okay. And I have listen. This is for everybody. This is absolutely not foreseen. I've asked in the meanwhile to our colleagues in the background if they can prepare a poll. So we will send the poll after the event, asking you, and this is for everybody to know what happens here behind the scenes. You know that Manfred started, he said, priority for standardization needs are around emission parameters for noise mapping, so defining emission parameters for noise mapping depending on the low noise road surfaces, developing a standardized method for long-term performance of the pavements, common designation of the pavement, a standardization of the cost-benefit analysis, and now another topic, the common European tender or common tender specifications when you want to pave low noise road surfaces. So these are the 5 things that we've listed. You will get it through a poll, but our speakers will intervene one by one and anticipate their own opinion. Please, Fabienne.
Yeah, but I don't want to influence the poll. But to me, the common designation of pavements is the basis, because once we don't, since we don't agree on that, it's very complicated to talk together. So I would put that first. And after, I would say the emission parameters for mapping it's important. Of course, the long-term performance the long-term development of the performance of pavement is also the next one to be very important. And I would put after the common tender specification maybe. And last, but it doesn't mean that it's not important, but one has to be the last is the standardization of cost-benefit analysis, because maybe we are not fully ready for that now. So we still need some insight in that. But this is purely my opinion now. I'm not.
About the speak, so I try to say something about. I think the number 4, number 5 are based on the results on the other 3 before, because you cannot define a tender without the data that come from the 1 and 2 at least. And the number 3 is useful to define the precise which are the specifications. So, and the cost benefit analysis come for the same reason. It's based on data, objective data. So for the ranking about 1, 2, or 3, depending on also on the role that we play in the game. So for me, it's 1 because I do for that, but maybe for others it's different.
And in the meanwhile, and I thank you a lot, our colleagues in the background, they have placed on Slido the poll. So I invite everybody connected to push the button and give your own opinion. What do you think is mostly needed for standardization today?
My opinion, may I say something? My opinion is that the 5 points are connected as a sort of cause-effect chain, as Gaetano said, by the way, because from a cost-to-effect standpoint, the most important thing is the long-term development performance of payment. The common designation payments stays in the same position, but it is something easier, and it follows. And the point 4, by the way, it is you know that there is a European guide in order to carry out cost-benefit analysis for transportation infrastructures. There is already a EU guide. So my opinion is 2, as from a causal effect standpoint is the most important. By the way, if you really wanted to have a lot of low noise payment, the most important would be the 5. Because the 5 means economy, means real thing. But the second point is knowledge. Is the knowledge that sometimes we miss. That is my opinion.
Okay, Patrizia, floor is yours.
Well, I agree with Filippo about common tender specification, first point. And then I think maybe we should replace standardization of cost-benefit analysis with sustainability analysis. And then long-term development of pavements. and common designation of pavements, because we have seen we have many different types of pavements. So it is now a little bit confusing to choose one pavement with respect to another, and it is important to summarize all the experience made so far. And the last one is the emission parameters for mapping, just because this issue was in somewhat a result in the Life Dynamo project, in which the emission of the sources were measured directly, and noise mapping is achieved in real time without gathering information on parameters like those. We measure the emission from the source and we map directly the noise impact at receiver using information retrieved from the devices.
Bert and Ronald. So for the people, I think that you were answering the poll, but for everybody, just to refresh your mind in case you are not on Slido, well, first of all, go on Slido, it's your opportunity, and we like to get your input now. We are closing. So take your opportunity to signal us what you want from us. But to remind everybody, we are talking about 1, emission parameters for noise mapping, 2, long-term development of pavement, 3, the common designation of the pavement, 4, the standardization or of cost-benefit analysis, or as Patrizia signaled, the sustainability, yes, sustainability, which I think it's something I expect from Bert again. And the 5th, it was to have common tender specifications. Bert, Ronald.
Yes, sustainability, of course, is not on the list. So I agree. Yeah. But for the 5 that are here, I think 1, 2, and 3 should be on 1, 2, and 3 in any order. I think they should be combined. If you're going to do emission parameters, you should be clear about, are they lifetime average values? Are they for new pavements? Are they for old pavements? You cannot, and at least you need to know what pavements are we talking about. So I think 1, 2, and 3 are actually all 3 indispensable and important. And let me not only give these priority, but let me also formulate the deadline. I think the next round of noise mapping, Marco, starts in 2026, I think we should have this ready and finished by 2026, right? So let us focus the ambition that we have this up and running, this standard for the new round of noise mapping, round 5. How is that ambition for you, Marco? And also maybe the CINEA working group.
Thank you very much. I don't know if Giulia, you're still connected and you want also to give your opinion.
Yes, I am connected, but I don't know how to rate. I think that everything is important. I'm really lost.
Okay, we get 1 point for each of the 5 options. Okay, we will collate it to the other one. Thank you, Giulia. Thank you.
We cannot hear you, Marco.
And we have the result from the poll. I don't know if I can put it on the screen, but I will spell it out. With almost 4 points, I guess, like this 80% of the people. The best one is development of the long-term performance of pavement. And a common designation of pavement is what the audience want. Then there's a second. The third one, they want to focus on emission parameters for noise mapping. So standardization of how to collect the emission parameters for noise mapping. And the 4th relevant, the standardization of cost-benefit analysis, or in the correct interpretation of Patrizia and Bert, sustainability cost analysis. And common tender specification is the one that ranked last. But I have to admit that they were all pretty much voted in the same way. So there is not a huge difference between the last one and the first one, meaning that possibly we have a plan, and we have to work in the direction of these 5 all elements. And with this in mind, with 2027 next round of noise mapping, we have something to do. But not only from our side. Let me be frank. We started this webinar stating it is for you. And one of the ambitions of this webinar is that you've learned what are the different aspects of low noise road pavements, and that you will use this low noise road pavement even under the restrictive condition that there are some challenges in front of us. For instance, in standardization, we said, for instance, in the durability, for instance, in the maintenance, for instance, in deciding where exactly you have to adopt the solution. But the starting point for us was and still remained that the Zero Pollution Action Plan asks us to reduce by 30% by 2030 the number of people exposed to transport noise and affected and whose health is affected by transport noise. And on the top of that, we have road noise. One thing is clear, even though Gaetano signaled that there are different options depending on the situation, but this solution seems to remain a fundamental solution to be implemented broadly. Therefore, there's a challenge for you. Use it, implement it in your call for tenders, and a challenge for us. We will come up with guidelines, with standardization, and with a plan to disseminate this standardization and this guidelines so that we standardize to the point that it is useful for you and for everybody. With this in mind, I think that Manuel would also to say a few words before we head towards a conclusion.
No, I see that, Marco, you have been covering everything pretty well. So I just to say thank you to everyone. Thank you to the speakers. Thank you for your availability and to spend the whole day with us, like sharing your knowledge and experience. It's always a pleasure. Thank you to my colleagues at the background, because this meeting is running because they are behind. There are a lot of people working to make sure that everything is working properly and explaining us what to do and when and so on and so forth. So that is from my side. And I would like to go back to how I started this morning. The meeting is like, if you have good idea about covering this topic, the topic of noise, and I see that there are so many people on this area now here with us. So the life is a possibility. So consider that is an option, and it's always good and very important and relevant to work with colleagues with different backgrounds from different countries, from different regions, to try to put forward product ideas. So life funding is an option. And with that, I think that I don't have anything else to say. Just thank you so much for the day. It was very fruitful and interesting. I learned a lot, as always.
It is my duty to mention that behind the scenes, we had an excellent team composed by Oksana, Oskars, Aiga, Isabella, Cesar, and last but not least, Manuel here next to me. Be aware that this webinar was thanks to them. Thanks to Giulia, Manfred, Patrizia, Bert, Ronald, Filippo, Fabienne, Gaetano, and thanks to all of you behind the screen. Thank you for being with us up to the end. There was some drop of connection, but I think we are almost 150 people still connected. After a full day online, that was a signal that we are going in the right direction. Thank you very much. Goodbye.
Thank you to you, Marco. He was in the driving seat, making a lot of noise.
Yes.
Thank you.
We will. Low noise road surface. Ale, bye-bye.
Bye.
Bye.
Bye.